Hey Hero, how you doing? You ready for the test? I know, yeah. Which is good. Remember, and you also want to study smarter, not harder, which is great. And if you've been watching the videos, remember there's gonna be 5 FRQs. So the first thing you want to do is just make sure you recognize the FRQ. Is it a rate accumulation? Is it a graph analysis? Now, that's what I would think they would give you, because rate accumulation, that's fundamental to calculus. I mean, that's just calculus 101. You cannot have a calculus without a rate accumulation question. It's a real life scenario. So something has to go in, something's going out, something like that. So that would be my first question. My second one would be graph analysis, because all the previous years, they've always had graph analysis questions. The other one they've always had is the particle motion. And then the differential equation, that one's iffy. You don't know. It's every other. And then sometimes they throw like an oddball question. But this year I thought, you know what? If they throw an oddball question, man, that's really, really bad. Because with everything that's going on, and you're going to throw an oddball question, no, please don't do that. And I think they haven't done that. But what I have noticed from people I talked to, saying that there's going to be 9 parts. So the first question is going to be 60% of your overall grade. So that first question, hopefully it's a rate accumulation, and then it has that nice 9 parts. And if you do well on that one, I think you'll be well. The other one is worth 40%, and I'm hoping it's like a graph analysis or whatnot. But remember, they're asking the similar things always. They're asking, for example, rate accumulation. They're asking the rate of something going in, and then they're going to ask you that fundamental theorem of calculus. If you've seen the FRQs on rate accumulation, you'll be fine. And it's just thinking about, what to look for. You don't want to study. I don't want to say you don't want to study everything, but you want to fine tune and focus what you're going to study, because that's really, really going to help you understand. And if you look at it, and in the videos that I've done, they ask the same type of questions over and over and over again. If this is your first time taking the test because you postponed it for whatever reason, then just be ready for that. If you're taking it, if it's a retake, then you kind of have a layout. You know what? I know what to look for. Hopefully it's the same type. I hope they really, really don't, go off to left field and give you something crazy. But again, I don't know. Some people say that they just kind of randomly select them, but I don't know. These are professors, these are human beings, so I think they're really gonna just focus on the fundamentals. Rate accumulation, graph analysis. Those are the 2 biggest ones that I would put on. Particle motion, I don't know, but you got to be ready for it. Differential equation, you just got to be ready for it. All right, but that would be my first order. Rate accumulation, you got to know that. Graph analysis, you got to know that. And then it's your particle motion, differential equation. Remember, area and volume is not going to be on it. Yeah, hey Renee, thank you so much. You know what? And I hope that they're going to do the same thing. Because if I'm a teacher, right? And for whatever reason, a student, maybe they got sick, they couldn't retake it. And if I give them a totally different type of scenario question, that's really gonna suck. That's that's cold shot. Or the other thing I'm thinking too is, you worked hard, you did good on the first retake, and all of a sudden there's a glitch, and you're trying to upload, and it messes you up. That's not your fault. And then now you have to retake it, and then they give you a completely different type of question, and you're like, wait a minute, where did this come from? So that's gonna be difficult. I really, really hope they don't do that. Okay. Interpreting slope. Yeah, there's a slope field question. But you know what? If you see a slope field question, just okay, how do you do it? Basically separating the variables, right? and then put the y's together, put this together, and then just go step at a time, one step at a time. Remember, the first thing is recognizing the FRQ. Oh, rate accumulation. You have your notes right there. This is my rate accumulation notes. And then the second little pile have my graph analysis questions. And then my third little pile have, these type of questions. Okay. Yeah. Hey, Daniel. I really hope they don't put a differential equation. That would make it a lot easier. Related rates? No, I doubt it. I mean, if you look at the fundamentals, there's basically 5 types of FRQs. Your rate accumulation, the graph analysis, the rate accumulation that can come with a table as well. So be ready for that, okay? Particle motion, and that one you could also see a table, okay? And then differential equations. Differential equation, remember, it's every other. Okay, that's where they might throw an oddball like a related rates. Okay, area volume, that one's not going to be on the test, but that one is usually every single year you get area volume, but because of this year, you're not going to get it. But the related rates is like an oddball. I doubt, and if you go back and look at the exams from previous years, you'll see, you know what, that they don't put that on there. Okay, it's been rare. I think it's 2011, no. 2011 or 2001 that I saw it. I forgot which year, but it's been a long time. Okay, might be just part. I don't know, maybe. Could you simplify the integral of d prime? Oh, okay. Hey Hemlada. Yeah, you know what? D prime of t over 4 dt. Well, that looks like a u substitution, where you have to let u equal t over 4, and then du dt, du equals to yeah, whatever that is, 1/4, and then you would do the integral, the antiderivative of that. How do you find the critical points on an interval? Remember, these are the keywords: critical points. Well, critical point, you're talking about first derivative, right? All right, when it changes from what? Positive to negative. Critical points, remember, is from the graph of the derivative, right? So you have your x-axis, right? And if it goes from negative to positive, you got a critical point right there. Remember, critical point is when the first derivative, you set it equal to 0. Well, they're going to give you, if it's a graph analysis, they'll give you that first derivative. You set that equal to 0. That means where it crosses the x-axis right there. And then you see, oh, it goes from negative to positive. Oh, okay. Boom, there's a critical point. And then the other one, oh, there's another critical, goes from positive to negative. All right. And that's how you would do it if they give you one. Yeah, guys, you know what? And help each other out. Help each other out, guys. Remember, the more of you that are talking about this and helping each other out, the more comfortable you'll get. Okay. Now remember, there's only going to be 5 FRQs. All right. So fine tune it. Work smarter, not harder. It's going to be rate accumulations. Okay. And I think somebody told me there was a table for the first time. So I don't know what they're going to do this time. This graph analysis, and then of course your particle motion will be top 3, because those you always get them every year. And then your differential equations. All right. But help each other out. If a limit of a constant goes to infinity, does a limit exist or not? Depends on the function. So Niramai, it says if a limit. Hey, Japan, how you doing? I know they did. Oh my goodness, 5 a.m. I'm so sorry. I'm so sorry. But you know what, guys? Remember, this is about you. This is about you. I know you're angry, you're upset, but this is about you. The sweetest revenge is just you guys being successful and doing well on that AP exam. Stay focused, okay? So be able to recognize that FRQ and be able to have your notes right there. Have your notes. Some people have been having trouble with the calculator. Use desmos.com, on your phone, because you can do that. And remember, the only thing you can't do is have anybody help you, okay? Don't be tempted. Some people are going to be tempted by cheating. Don't do that, guys. It's not worth it. Believe me, you can do it. It's only 2 questions. And it looks like there's going to be 9 parts for the first one, 9 parts for the second one. The first question is going to be worth 60%, I believe, of your overall grade. And then the second one is 40%. I'm hoping the first question is a rate accumulation. Okay. And then, you know, that's fundamental to calculus. And then the second one, hopefully it's a graph analysis. I mean, but we really don't know. But Niramai says, if a limit of a constant goes to infinity, does that limit exist or no? Limit of a constant. I don't know if I understand the question. I mean, x approaches, for example. You mean if f of x was a constant? I'm thinking. I'm not too sure, but I think you mean if, for example, the limit as x approaches infinity of 2, right? Well, then the answer would just be, it does exist because it's only 2. I think that's what you're asking me for. Not too sure, but let me see here, guys. Hey, Elias, thank you so much, man. You know what? And I'm just, this is for you guys, man. I'm hoping you guys do well. Can you use L'Hopital's rule for 10 over 0? No, you can't. Remember, L'Hopital's rule is only 0 over 0, infinity over infinity. 10 over 0 would be just undefined. Good question, Himlada. Oh, yeah. Thank you so much for answering that, Nicholas. Tabular data is likely with Riemann sum. Yeah, Daniel. Yeah, I mean, I'm hoping they don't really deviate from the first part. Yeah, I'm hoping, guys. I'm hoping they just stay with the same structure. $10 over 0. No. Remember, you can't divide by 0, so man, Hemlat, I'm so sorry. I'd have to look at that question. I don't know if anybody else in the chat can answer that question. I think I'd probably have to see it. If it approaches an asymptote, yeah, I don't know. I'd have to see it. I'm sorry, Hemlata. Oh, a great calculator is Symbol Lab. Yeah, thank you, guys. 4 parts. The second question is only 15 minutes, so they're like, okay. Oh, that's good to know. Yeah, because I thought it would be more like you know, regular 4 parts to both, but I guess not. I didn't think the first part had 9 questions. How would you generally go about doing rate accumulation? Well, Nick, rate accumulation, you know what? Let me see if I can get one here. They're gonna ask the same thing. Like if they give you a rate, they're gonna ask you for an amount of some sort. So for example, like in 2018, they asked how many people enter. As soon as you see, if they give you a rate and they say how many, then integral, because remember, to get an amount, the integral of a rate gives you an amount. So they just go to the integral from, you know, 0 to 3 or whatever, plug that in your calculator, and that's it. Now remember, part A is usually the easiest part. You just kind of plug in something. It's really straightforward. Later on, remember, they're going to ask you for rate accumulation. They'll ask you for a max and minimum, okay? And the thing about rate accumulation, Nicholas, is you have to incorporate everything, okay? So there's going to be something that's already there, initial condition, right? Maybe there's 20 people waiting in line. And then they're going to give you a rate of something that's going in. And then they're going to give you a rate of maybe something that's going out. So you're going to have to come up with a general equation for everything. Okay. So then it'll be, you know, maybe 20 plus the, you know, the integral of RT dt. Why the integral? Because you want the amount A of t of everything. Okay. Because they're going to ask you how many people are at the end of 300 seconds, right? Okay. Well, there's 20 people waiting in line. Plus, why plus? Because people are coming in to the elevator. The integral of what? RT dt. When you integrate a rate, you get an amount. Minus, why minus? Because people are exiting, they're coming out. Exiting what? And then whatever that rate is. Okay? And then they're going to ask you for when is it the maximum or the minimum. So what do you do then? You take your equation, right? First derivative, set it equal to 0, find your critical points and number line. So you take your A of t, you take the derivative, and then you set it equal to 0, find your critical points, and then you're going to have to find, you know, your critical points plus your 2 endpoints. Okay? And hopefully that makes sense. But normally that's what they do. Can you apply the fundamental theorem of calculus? How to apply that? The fundamental theorem of calculus, that's the integral from a to b of f of x dx. Then you go f of b minus f of a, and then you're going to switch it around, if that makes sense. Do I have an example here? But I know the other, I have it in the other videos, guys. Let me see if I can give an example here. So I can find it, guys. Let me see the question I can answer. Can we justify that there's an extrema by saying we use the candidates test? That'll give you like a partial. You got to make sure, because it goes from negative to positive, or if it goes from positive to negative. All right, you can say, for example, they give you the graph analysis, why is it a minimum? Because it goes, the graph goes from negative to positive. That would be sufficient. Because 10 candidates test, remember, these are human beings. I don't know. I really don't know. I mean, we're calculus teachers. We understand what candidates test means. And I think, I don't think it would suffice, though. Because all the gradings that I've seen, they've given that reason. You know, it goes from negative to positive or positive to negative. Okay. But good question, Mags. Okay, symbol lab, practice with it. Yeah. Yeah, guys. Hey, Hazel, thank you so much. How many questions are on the exam? There's going to be 2 questions. Praise the sun. There's only 2 questions. The first question, guys, remember, for those of you that are just got on, it's 60% of your overall grade, and the second question is 40%. I'm hoping, I'm really, really, really hoping that the first question is a rate accumulation, and they just kind of keep the same format. The second question, graph analysis, I don't know. But I mean, you just don't know, guys. But graph rate accumulation, graph analysis, make sure you know that particle motion, make sure you know that differential equations. Okay, and I really hope they don't throw an oddball out there. If they throw an oddball, it would be maybe like, I'm hoping that they just do like the product rule, chain rule, you know, that sort of stuff. All right, yeah, Elias, yeah, that's good. The fundamental theorem of calculus, Johannes. Let me see if I can find one here. Show it to you guys. Well, Elias, thank you, but I think you guys are the ones who put in the hard work, guys. I know this kind of sucks, but All right. This is from 2017, guys. I don't know if you can see it. I hope you guys make sense. I don't know. But 2017, Elias. I don't know if you guys see it backwards, but it says find the values of f of -6 and f of 5. So what do? They give you the initial condition f of -2. F of -2 equals 7. Okay. So if it looks weird, this is from 2017 graph analysis. So if you want to go check out those videos, all right, because it says find the values of f of -6, f of 5, and that's fundamental. And when you see that, you know what? I'm already thinking integral, okay, because this guy is a rate. This is the derivative. Okay, this is the derivative, and they're gonna ask you for, you know what? Find f of 6. So you got to do the integral from where to where? Well, where do they start? -2. What are they asking me for? -6. And then you go the integral from -2 to -6, and then you do the fundamental theorem of calculus. So f of -6 minus f of -2. All right, and then you have to rearrange it. You see that? You have to rearrange it. Bring the solve for f of -6, and then you get the initial condition, and then with the integral. But I don't think you guys. I think it looks backwards. But Elias, this is 2017. Okay, guys. When do you use L'Hopital's rules? When it's 0 over 0 or infinity over infinity. Remember, 0 over any number is going to be 0. 10 over 0 or anything over 0 it's going to be undefined. But when you get infinity over infinity, 0 over 0, use L'Hopital's rule. Find the equation for the girl running laps. I don't know. Both questions have 8 parts. What percentage of 5? No, it's okay. I don't know what percentage of 5, guys. Well, normally each question is worth 9 points, 9 and 9, and I remember. Well, normally the test, if you get about 60%, that's a 5. Like 61, 62%, that's a 5. 48% somewhere on there, that's a 4. 36%, that's like a 3. So it's very doable. I don't know how they're going to do the grading this year, but I do know that the first question is 60%, worth 60%. So really try to, hopefully it's a rate accumulation. Hopefully hammer that one out really good. Second one is worth 40%. Okay. How do you find the value of differentiable functions when looking at its graph? Taka, how do you find the value of a differentiable function when looking at its graph? You basically do, for example, let's say they're asking for f of 6, right? Or like in 2017, this 2017 question. They're going to give you initial condition. Because remember, this is the first derivative. So you want to do the integral from the initial condition, which is, for this one is -2, from -2 to whatever they're asking you, f of 6. Do the fundamental theorem of calculus, which would be f of 6 minus f of -2. Rearrange it to solve for f of 6. And then, well, how do you do the integral? Well, the integral, remember, is the area underneath the curve. So then you would use a graph to find the area underneath the curve. And that's how you would find it. Yeah, hopefully that makes sense. Okay. Siddhartha says, how do you find what's wrong with the slope field when it asks you to find a composite equation? It was there last time and made no sense. Okay. Siddhartha, for well, remember, when you guys get a question, just go step by step. So what I would do if I saw a question, okay, what is it? A slow field. Okay, well, what do we do with a slow field, right? We either graph it, right? Or then we start solving it. We start separating our variables, right? And so we separate the y's with the x, do the antiderivative, then start solving it. And then just go step by step. And it just depends on what the question asks you. Think about the scenario. I mean, I don't know. It would just have to, based on the scenario that they give you. But if I see a slow field question, then I'm okay. Well, let me separate the variables, and hopefully doing that, you can see what's going on. And remember, guys, the objective is to understand what the question is asking you. So rate accumulation, for example, you got to understand, well, what's going on. Don't just go in there. Okay, what are the steps? You know, and no, what's going on? Give yourself a mental image of what's going on. Okay, 20 people are waiting in line. Okay, there's this rate of people going into the elevator or escalator. Okay, and then this is the rate of people going out of the escalator. Okay, so it gives you a whole picture. So rate accumulation, you have to incorporate all of that. What's there, what's going in. So what's going in, what's going to happen? It's going to be a plus because they're going in. And then what? And then minus. Why minus? Because it's coming out. Okay, and then that helps you understand the question overall. Okay, lags exam, we got graph analysis and rate accumulation. Can we expect? Benny, I don't know. Really, I don't know. If it was me, I would say yeah, right? Because it would suck if, you know what, you worked so hard, you did well. All right, I'm doing it, I got it, and then you're uploading, and then there's a glitch, which is not your fault, and you're, wait a minute, what's going on? And now you got to do this thing all over again. And now the second time around, they give you something totally out of left field. And you're thinking, wait a minute, what's this? It's an oddball question. What? I mean, I would think, you know, I'm just thinking as a teacher, you would try to keep it relatively the same. But I don't know. I really don't have no insight into that. I really don't know. But that's why I'm saying, make sure you know rate accumulation. That's fundamental to calculus. Make sure you know graph analysis. Make sure you know the particle motion. Make sure you know your differential equations. Have your little stack of notes right there. Boom, boom, boom. Have your little stack of notes, and that way, I think that'll guide you. And that's very helpful because this year that's what they're doing, right? And if you have that, you have your calculator, Symbol Lab, or Desmos.com to help you with the graphing. You know, I think it'll give you a good chance. Eshna, if you're running out of time from one problem, and I know it's just what to do, but there's not enough time to finish it. Yes, finish it. Finish it. I don't know if you're retaking it, Eshna, but if you're retaking it, then you have an idea of how to upload it. And I believe, guys, I believe you're able to email your responses this time around. I'm not sure. I think you are. Can somebody confirm that? How much time should you save for download? 5 minutes, guys. 5 minutes. Are there common related rate problems? Eshna, there hasn't been a related rate problem in years. So I doubt that they would start. I mean, it's not that it's not important, but with all the material and content you guys have to know, that's kind of like an oddball question. I really hope they don't do that. When we're showing our work for minimum maximum, we show that f prime of x equals 0, critical point. Great question, Alex. Alex says no. Remember, these are human beings. They're looking for the answer. You don't have to write everything down. A lot of us are visual. You can just put arrows, and because if I'm a teacher, I'm like, okay, does this person understand what they're doing? Oh yeah, look at, there's a number line, there's a critical point. You can put critical point. You can put max to min. You can, yes, that should be enough to explain it. Because remember, you have to demonstrate. You don't just have to put everything in words. Now, for example, critical point. Yeah, you said I think the only thing you have to do is make sure you put it goes from positive to negative. The graph goes from negative to positive, and that's why it's a minimum. Okay, something like that. It doesn't have to be, long and drawn out. You can use a number line and visuals. Hazel, if they ask for a max and min for rate accumulation, then can we just set the rate to 0? Not quite, Hazel. For the rate accumulation, remember, you have to incorporate everything that's going on. Normally, it's going to be a real life scenario. So you do, like the 2000, I think is 18, the escalator problem, right? You have 20 people waiting in line. You have people getting on, and you have people getting off. So you got to create a general equation of the whole thing. So you got to do 20 plus the y plus because people are getting in. The integral of that RT dt minus y minus because people are coming off. So that's your general equation. From there, you take the derivative and then set it equal to 0, right? And we take the derivative, you get rid of the integral. Find your critical points, and then you use your critical points to find the value. You find your critical points, right? Maybe 2 of them, and then you got to make sure you use the other ones to the endpoints. Okay. You see, I'm trying to get to all the questions, guys. So you guys have a lot of good questions. Hopefully, you guys can help me out and help each other out as well. Okay. No, it's okay. Rate accumulation is Riemann sum. You might get a rate accumulation, because remember, they're going to give you a rate, and it might be as a form of a table. Okay, they might give you that, and then you're talking about Riemann sum, left hand, right hand, midpoint. Okay. You guys have a lot of questions, guys. I'm trying to get through. Okay. Brandon says if you fail to submit, you'll be directed to request a makeup. I don't know. Alex says my teacher told us they'll be the same. Be nice, huh? It would be nice. I don't know, guys. I really, really, really don't know. Yeah, because most likely people probably took screenshots, showed their friends or something. I don't know. They're not supposed to, but if you're a senior and you're done with AP Calc, and I would think it would be different. You just email them your answers? Yeah. Maybe some related rates. Brandon, I don't know. I hope not. I hope not. Because the reason I say that is because this guy is saying the AP coordinator said, you know what? It's not going to be different than any other years. It's going to be relatively the same. And there hasn't been a related rate problem since, I believe, 2000 and it's either 2001 or 2011, one of those two. So we're talking about 9 years. Okay. It's been a while. There is a June 22nd, Elizabeth? Oh, wow. I had no idea. When they ask for local relative minimum max, I don't do endpoints, right? Lily, now you got to be careful. If they ask you find the minimum, if they ask you for find the minimum or find the maximum, right? Correct. You're right. You just find the critical point. There's a minimum at this point. If they ask, find the minimum value, that's a whole different story. Because now they ask you for the minimum value. They're not asking you for x equals 2. They're asking you at x equals 2, what is that value? So now you're asking for the y value. So that's when, remember, if they ask you for the minimum value, like, let's see, 2017, you see? Gosh, I hope you guys can see it. Part C, it says, find the absolute minimum what? Value. So when I see that, I gotta do my critical points and the endpoints. But if they just ask me, find the minimum of the graph on the interval from this to that, then yeah, you're right. So hopefully that makes sense, Lily. Matthew, sorry, Matthew, let me see your question. Rate accumulation is usually presented in a table, not normally. Rate accumulation, it could be either or. The reason I was guessing it was going to be a table because in 2018 they gave you 2 equations. 2017 they gave you 2 equations. 2019 they gave you 2 equations. So I'm thinking, you know what, they're probably due for a table type of a question. And I think I was right. I'm just guessing, guys. But you know, I'm just going based on patterns. But it could either be either or, Matthew. So just be ready for that, okay? My teacher meant there's Alex type of meaning there's likely okay. There's likely another graph analysis. I would think so. That would just be common sense to me. If they do something totally different, then that's just cold blooded. You know, that's just sad. But I hope so, Alex. Eshna, I'm so happy that it's helping you guys out. I did it for my students because of all this COVID thing, but if it can help you guys just understand and move forward, then that's what matters. And I'm glad that you guys have been doing a great job. You guys are helping each other out, and which is great, man. So just kind of fine tuning little things here and there. Infinite sequence and series content. If that would mess me up really bad on this BC. Infinite sequence and series. Omar, I would say print out all the tests that you have, you know, of the series, okay? Just to have it, because remember, you can use your notes, but that is fundamental. The P series, you know, the convergence test, divergence test. Make sure you have notes on that then if you're not strong on that. And that's a BC question. Hey, Robo King, Euler's method, Euler's method. Well, Euler's Robo is start off with writing the equation and finding the slope using the derivative. I'd have to give you an example and do a video to give you a better explanation of that. And then just use that value to create another one, another set of points. But I'd have to show you. And I'm sorry, man. There's so many questions. I wish I could do all of them, guys. I'm so sorry. Basic topics to take notes because I'm under A, so I don't know. Find any basic topics to take notes. I'm not too sure, Eshna. Basic topics to take notes. I don't know if somebody else can help answer that, guys. Well, slope fields. Let me see here. Well, a slope field, Bilal, is a differential equation. Okay. If you do the antiderivative, you get the original equation. Okay. You get the original equation. And a slope field is basically the solutions of the original graph, the basic solutions. Because remember, when you take an integral, you see how you have always that c. The integral of, I don't know, let's say of x, right? You're gonna get x squared plus c. And if you have x squared plus c, that means you can have all these parabolas at different points. Okay, so let me see if I can do a differential equation real quick. And let's see here. Desmos. See if I can do this. I don't know if you guys can see that. That's kind of hard to see. But see, that's a differential equation for x, because the antiderivative of x is x squared. So these are all x squares, and they're all different positions because you know, you have x squared plus c, so you have a lot of different possibilities for the original one. But I just did that on Desmos, Bilal. I don't know if, hopefully that makes sense. I mean, I think we'd have to do a video or an example for that. But I think for that one, Bilal, for slope field, just start separating them. And the one thing about slope fields you gotta understand is they are the solutions to the original. Okay, so if it looks like, oh, it's a parabola, that means the original was a parabola, x squared. Because if you take the derivative of x squared, then you get what you're looking at. Okay, if you have, oh, it looks like x cubed, right? Okay, that's because it probably is. And if you take the derivative of x cubed, then you're going to get 3x squared, which is what you see on the slope field. Hopefully that makes sense. Yeah, slope field would, I don't know, it would be kind of like an oddball, guys. Slope field graph. Yeah. Hey, Benny. I like to use Desmos. For example, a lot of times they'll ask you to find the point of intersection, right? Critical points. In 2017, somebody else was having trouble with the calculator. So I did a quick video, and all I did is I put RT. I graphed it because that's the rate, and they gave it to me already. So I just put that, and I had to set it equal to 0.7. So I just put y equals 0.7. And I was able to manipulate it and move it and just say, okay, I click where I thought they intersect, and it just gave it to me. And so I like Desmo. Somebody was saying Symbol Lab, but you got to practice with it. Yeah, Desmos is great. Are the problems or the solutions released from the May test? No, they're not. Not yet, Deborah. I think it'll be till July. You guys are getting your results, I believe, July 15th. Oh, GoodX, Desmos can even help derive and integrate. Wow, that's cool. Yeah, no, I believe you're right. Just plug it in. You're right. You're absolutely right, GoodX. You're absolutely right. You're absolutely right. I forgot about that. That's a great point. Very, very well done. Man, I'm so glad for you guys. You would go to functions, miscellaneous. You see that? And then you have your where is it here? This is your integral right there. Boom. And then you just go from whatever let's just put square root of 5 to 3. And then I don't know, let's do 4x squared and then dx. And there it is. You see that? Hey, great job. Great job, GoodX. Thank you so much. I forgot about that. Somebody says slow fields won't be on the exam. I hope not. Riemann Sum. Hey, Grace. Riemann Sum. They're going to give you a table. Remember, for Riemann Sum, they're either going to ask you left hand, right hand, or midpoint. So if they ask you for left hand, because remember, all these are Riemann Sum is just rectangles. Okay. So you see here, this one they use, it says, use the correct units. This is a particle motion. It says use a right Riemann sum with 4 subintervals. You see that? So I like to draw my little rectangles, and I put a dot on the right. Because remember, what's a rectangle? How do you find the area of a rectangle? Base times the height, the perpendicular height. So what's the base? It's the x value. So remember, time is always your independent x value. Okay? So for this one, what's the distance from 0 to 12? 12 times what? 200. That's your first rectangle. Plus, and then what? The distance from 12 to 20 is what? 8. 8 times what? 240. And the distance from 20 to 24 is what? 4. 4 times what? Negative 220. And then the distance from 24 to 40 is another, was that 16 times 150. Now that's a left-hand Riemann sum. The trapezoidal sum It's a little bit. That's the odd one, because remember it's got to be divided by 2. So but I have a video on that as well. It would be kind of hard to explain right now through the chat. But the trapezoidal rule is where you're adding the 2 y values, right? What's the distance? The x value. What's the distance, right? And it would be, let's say we were using this one. So from 0 to 12, what's that distance? 12, okay? But then you have to add the 2 y values, 0 plus 200 divided by 2. Why divided by 2? Because that's part of the trapezoidal formula. Okay, and then for example, from 12 to 20, what's that distance? 8, right? And then you add what? 200 plus 240 divided by 2, because it's a trapezoidal. Hopefully that made sense. Has anyone seen a particle motion question on the May test? So hopefully, Grace, that makes sense. A good question. Do I think there'll be any slow field problems or related rates? Related rates, that's an oddball for me. I don't think so. Slow field, maybe. I don't know. Somebody was saying that they think they've been told by their teacher that it's going to be similar, right? Rate accumulation, graph analysis. We don't really know. Honestly, we don't. But I always tell my students, you're going to have basically 5. You have rate accumulation, number 1. That's always every year. You always get that. Graph analysis, okay? Always get that. Particle motion, I think always, you've been getting that one every single year for the last, I don't know how many, 10, 15, 20 years, I don't know. And then differential equations, that's kind of hit or miss. That's kind of like every other, kind of weird. So that one I could see them switching it out. 2019, I think they threw an oddball in there. I hope they don't do that for this retake. I just really don't. I really hope they don't. And yeah, slow field, I don't know. Why they recommend number 4 centered volume? I have no idea. When it's a right Riemann sum, it's an overestimate, right? It depends, good X. Think about it. If the graph is going up, right? If the graph is going up, right? I'm trying to do this backwards. And it's the right part of the curve hits it, right? Okay, I'd have to draw it for you. Let me see if I can do that real quick here. Because if not, I'll get myself confused as well. And we're more visuals, right? Sorry, I messed up a little bit here. But you notice this one's going up. It's increasing. And the right corner is touching the graph. So this guy's an overestimate. But this is the graph increasing. Now over here, the graph is what? Decreasing, and the right corner is touching it. So this would be an underestimate. So it depends. And I would just say, just pay attention if it's increasing or decreasing. And do it that way. Okay, but what did I do? I created myself a visual, so now I understand it. Tiffany, yes, you're absolutely right. The mean value theorem, if it has to be continuous and differentiable, then there exists a C. Great job. Rodolfo. Yeah, I don't know, but anytime we're talking about Riemann sum, the trapezoidal rule is always in there. You know what? Remember, guys, you can use notes. Okay, use notes. If you know trapezoidal, hey, I don't know that. You know what? Have it right there. Have it right there, right next to you. Okay. If you know Riemann sum, right, left, do I need notes for that? No, you don't. Just use your trapezoid, whatever it is you need to. And remember, use your time wisely, because your notes, if you spend the whole time looking at your notes, then you're gonna run out of time, and that's what we don't want. James, I'm so sorry. I'm so sorry, man. Yeah, I know it's not your fault. It's not your fault. It's not your fault. Bear down. It says, I have a question on approximating Riemann sums based on concavity. Well, usually when they ask Riemann sums based on concavity, Riemann sums, you're talking about a rate, and when they give you a rate, it's an amount. The way I think they could see it is, because remember, concavity is the second derivative. The second derivative. So usually they would give you a table, and it'll probably be the first derivative or part of the original function. But if it's the first derivative, then you'd have to do the second derivative. You'd have to take the slope of 2 points to find the second derivative. And if that value comes out to be negative, then that could be that's that concave down. But usually they don't ask those type of questions. And what I did is I looked at the previous FRQs and I thought, what are they asking? And you can notice, if you've seen the videos, they ask the same things. They don't really deviate from that, because they're fundamental. And once you start getting the hang of what they're asking, you're able to see it a little bit better. Riemann sum as a definite integral. Will you see a Riemann sum? So for Dunzo, for that one, what they could do is they could give you a table of a rate. See, like this one? That's a rate. And what do they ask me for? What's the integral, right? From 0 to 40 of absolute value of vt dt. So yeah, that they can give you that. And what do you have to do? And they tell you using a what? A right Riemann sum. And so then that's how they would throw in the table in there. And then what do? You have to use the Riemann sum to get the integral. And remember, the absolute value of velocity is the speed. Okay. Taylor for slope field, because we don't know if they give you another slope field. Remember, you have to understand what they're asking you based on the question. And anytime I see slope field is, you know what? Separate the variables. Separate the variables. Start separating it. Because remember, the slope field, if you see the original equation, you're able to understand, okay, what's going on. Okay. So that's what I would do. First, understand the scenario, because we don't know the scenario, and then separate the variables. Try to do that, just what we normally do, and then analyze it from there, because that's what's going to tell you. We really don't know based on the situation, because it's a real life situation. Let me see here. Benny. Rodolfo, with your luck, no. Remember, guys, just make sure if you understand the problem, the FRQ, then you go ahead and just go from there. Oh, FRQ. Okay, what are you looking for? And it's pretty straightforward. Rate accumulation, particle motion, whatever it is. And then, like I tell people, have your notes for this year's exam. Have your notes right there, and then that'll help you out a lot. Okay. And I tell students, don't focus on, oh my goodness, I gotta do this, I gotta do that, you look at the question like all these parts. Oh, what A through H, and you're looking at the time, you're freaking out. Don't do that. Part A, just recognize the FRQ. Okay, what is it? Graph analysis. Okay, I know what they're gonna ask me. They ask me for a minimum, a maximum. They're gonna ask me for concavity somewhere. Okay, and then you just start doing that. Okay, and then from there, you can go ahead and just answer the question. Give me a second, guys. Let me connect. I'll be right back. You're welcome, guys. So it is going to be stressful a little bit, but just focus on the process. Part A, okay, what are they asking for? Part B, okay, stay focused. What are they asking for? Because if you've seen the videos and you know, okay, you kind of know, fine-tune what they're going to ask you, okay, you're focused on that. Because really, guys, they don't deviate from much from that. If you notice all the questions about rate accumulation, same thing. How many this? How many that? What's the maximum number of people? What's the minimum number of this? You're always going to have to find your general equation. You're always going to have to take the derivative. You're going to have to do the fundamental thermocalculus. Graph analysis. Okay, find the critical points. Find when it's increasing. Find when it's concave down. Same thing. If you can see that, guys, you'll be on the right track. Okay, particle motion. When is the object going left? Well, when velocity is negative. Okay, what does the absolute value of VT dt mean? What does VT? Find this, right? Riemann sum. It's all pretty much the same. Okay, they tweak it a little bit here and there, but the fundamentals are essentially the same. Now remember, guys, nine points. Okay. And normally on the original test, the regular test, 60% is a 5. That's a D. I think we can all get a D on a test, right? So I know we would all like to answer all of it, but just stay focused on, you know what, just if you miss one part, you know, it hurts, but it's okay. It's not the end of the world, you know? And I would say, Taylor, have your notes on slow fields there, and that way you can use the notes. But normally slow field, just do the antiderivative, separate your variables. Hazel is asking, how do we know when to use open and close intervals? Well, that's a great question, Hazel. Let's do it this way, right? So right here, right, the graph is increasing, right? And afterwards, it's decreasing. Let me give it a value. Let's say it's 3. Well, what's happening at x equals 3, Hazel? You say, well, the slope is 0, right? It's a horizontal tangent. Correct. So at x equals 3, it's not increasing. It's not decreasing. Nothing's happening. So that's when you would use an open interval, right? Because it's increasing, increasing, increasing. It reaches to the top. Hey, what does it reach? It reaches the max. It reaches horizontal tangency. So it's not increasing anymore. So then I would use an open interval right there. Okay, so hopefully that makes sense, Hazel. What should I have for my notes? Drager, you should have, for example, rate accumulation, your little notes there. It depends what you need. Like, for example, if you don't know trapezoidal rule, have it right there with you. If you know right hand, left hand Riemann sum, you don't need your notes for that. Look at, if you've gone through the videos, you can see, okay, what are they going to ask? Man, I'm not really good with graph analysis. Okay, you have your little stack there of graph analysis. And then your notes that you've been taking. This is all my graph analysis. Underline, okay, what do they usually ask? And you have your little note stack right there of what they're going to ask. Same thing with particle motion. Same thing with differential equations. Okay. And sometimes I tell my students just to print out those, old AP exams, like, right, like I have here, right, because I can use these as mine. These are my notes. I did these, right, and I'm allowed to do that. These are out, and so I would just have that because they're gonna ask the same type of questions. Remember, guys, they want you to pass. They're on your side. Sometimes things are out of their control, but they really want you to pass. So hopefully that helps, Drager. Thank you so much, Tiffany, for helping out. How you do mid Riemann sum? Zhang, so you see here? So this is a right-hand Riemann sum, right? So if we were doing middle, we would have to use 3, 1, 2, 3, and we would go from 0 to 20, and then we would use the middle value, the middle y value, which would be 200. So the distance from 0 to 20 is 20 times the middle value, the middle y value, which is 200. Okay? And so there would be 1 here from 0 to 20, and then from 20 to 40. So from 20 to 40, if we want to do the midpoint, we would go from 20 to 40. That's 20 on the x, that's the base. And then what's the value, the y value of the middle? It's negative 220. So then I would multiply it by negative 220 because that's the middle of the rectangle, if that makes sense. I hope it does. How would you find if an overestimate or underestimate on the midpoint? Same thing. You would, I would say, Stephen, draw it out. And you can go ahead and, right, you can draw it out like this. Do your values and see if it's in the middle, right? If it's increasing, right, like this guy here, look at midpoint, the middle would be there. So you can see this is an overestimate. If you're doing it here, right, this is decreasing, then the middle would be here. I don't know if you guys see it backwards like I do. If you do, I'm sorry, guys. But draw it out. I think a lot of them are more visual than anything. Can you sign in at the laptop and a phone at the same time? No, you can't. I believe you cannot. You have to use one or the other. So whatever device you're going to use to submit, use that one. So use your phone if you're going to use that to submit, and then maybe have your laptop if for whatever it is you need to for notes or Desmos or whatnot for the graphing calculator. Differential equations. I don't know, M. There was apparently the first time around. You just got to be ready for it. It looks like it was one of the parts. Is there likely a chance of having to use separation of variables? Yeah, Eshna. Anytime you're dealing with differential equation, that's fundamental to differential equation, separating them. Okay. Were there any oddball questions? I think 2018 was there. Oh, I don't know. I don't remember. I think it was 2018 probably, where they kind of threw in like a limit, the limit of h of x over some variable, and then they ask you, okay, find the derivative, and then you had to use like quotient rule. So that one was a little bit related rates. Hasn't been a related rate in a long time. I doubt that they're gonna start putting it on, and I haven't heard anything. Can I go over the integral of x times f prime of 4 minus x squared dx? Good question, Nick. That one looks like it's going to be u substitution. Let u equal 4 minus x squared, and then you're going to get du is equal to negative 2x dx. So your x dx is going to be right there, and you're going to divide by negative 2, so you're going to have that negative 1/2. Negative 1/2 du is equal to x dx, which is going to be able to fill in the integral. So you do use substitution with that. Hopefully that makes sense. Optimization problems? No, I doubt it. There hasn't been an optimization problem. Gosh, I don't even know if there has ever been an optimization problem. But no, all the people I talk to tell me no. It's not that it's not good, but it just usually they don't put that on there. Related rates hasn't been on the exam. I don't know if it's 2011 or 2001. Differential equations, maybe. Last time I believe they said there was, so. What would you say is the most importantly thing to review during these last few hours? Fundamental to calculus, rate accumulation. Fundamental to calculus, graph analysis. Those are my top two, and then particle motion. I mean, those questions have been on the test every single year for the last, I don't know, 10, 15, 20 years, I think. So those are my top three. And you're only getting 2 questions. So those will be my top 3. Differential equations after that. That's kind of every other. And there was a differential equation. Let me see. Yeah, differential equation. Sometimes sometimes they don't give it to you. They throw an oddball instead of a differential equation. When are the scores for this makeup exam released? July 15th. July 15th, Daniel. Are rates on the test possibly? Are Ashan, yeah, related rates? I don't think so. That would be the really oddball question. There are 30 sets of tests. Yeah, I don't know. Sometimes, yeah, they say, that's what I heard. There's a randomization, and they just kind of pick it up. I don't know. I really don't know. I mean, I'm just thinking as a human being. If I'm a professor at a college and I need to make sure that they're getting ready, fundamental to calculus is that rate accumulation question. And it's been on the test every single year. Fundamental to calculus is that graph analysis question. It's been there every single year. Fundamental to calculus is that particle motion. Has been every single year. It just how it is. But see, this time around, this is not the original. This is the makeup. So I don't know. I really don't know what they're gonna throw at me, but I'll make sure I know my rate accumulation, graph analysis, make sure I know my particle motion, make sure I know my and then the differential equation. Remember, area and volume is not gonna be on there. Okay. Difference. Give me 1 second, guys. I'll be right back. Let's see here. Difference between right-hand Riemann sum and left Riemann sum. So Benny, this would be a right-hand Riemann sum, right? And what I do, I tell my students draw the rectangle, and you see the right corner because I'm gonna have to use the right height, the height of the y value here on the right side. If it was a left Riemann sum, then I would use the other one, this part right here. Same thing. That's why I put the dots, so I can tell myself which y value I need to use. Okay, guys. Hopefully that helps, Benny. How many questions can we miss? I don't know, Yukai. I don't. Normally, each test is worth 9 points, right? 9 for the first, 9 for the second. And then what I would do with my students originally, if you get like 60% of the questions right on the test, you're pretty much guaranteed to be closer on a 5. If you get, I think it's like 48% is a 4, somewhere on there. 36%, I think, is a 3, somewhere around there. Okay. I mean, 60%, you think, oh, we can do that. That's a D, right? Yeah. But don't think about that. Think about, you know, recognizing the FRQ. And then after you recognize the FRQ, okay, well then, all right, what are they going to ask? Rate accumulation. Okay, boom, this is, have my mindset on this. Okay. Because they pretty much ask us the same type of things. Okay. And then just concentrate on answering all the questions. Remember, the first few parts should be pretty straightforward and easy. Okay. And then maybe the other parts you might have to incorporate other information. How do you know when to use the first fundamental theorem of when it asks for a value? Well, the first fundamental theorem, that's a graph analysis, Annabelle. And they'll probably ask you find f of 6 or something like that. And they'll give you a graph analysis, and you're gonna have to find the integral, because they give you the graph. Let me see if I have. See, like for 2017 part A, find the value of f of -6 or f of 5. So as soon as I see that, then I see, okay, because this is the graph, right? This is the derivative. This is f prime. So what do they want? They want f. So how do I get f from f prime? You do the integral. The integral of what? The integral of f prime will give me f. Makes sense. Well, then from where to where? Well, where do the initial condition, they tell you, for this one, they tell you is -2. Okay, so you go from -2, well, to what? What are they asking for? F of 5. Okay, so you're going to go from -2 to 5. And then you do your fundamental theorem, f of 5 minus f of -2. Rearrange it and solve for f of 5. And then they give you the initial condition. And then, well, then how do you find the integral? The integral would be the area underneath the curve. Okay? Now remember, the area underneath the curve is between the x-axis and the curve, okay? The x-axis and the curve. Hopefully that helps, Annabelle. Man, guys, so many good questions. But hopefully, from seeing the videos, you guys kind of see, hey, you start seeing a pattern. It's like, hey, this is, it starts to show the same thing. That's the same thing. So it's not too bad. The two, let me see here. And about the second question, the extreme value theorem, finding the absolute maxes and minimums. I think you're talking about the graph analysis, and they ask you for find the absolute minimum value, the absolute maximum value. And that one, let me see here. Is this one? Part C here. Well, remember, anytime they ask you for absolute minimum, absolute maximum, right, minimum, maximum, what are you thinking? First derivative, set it equal to 0. Critical points, number line. Okay, and that's what you do. So you take your first derivative. Well, what's my first derivative? Hey, they gave it to me. There it is. Set it equal to 0. Where is it equal to 0? Right there where it crosses the x-axis. Boom, boom. Those are my critical points. Okay. And then if they ask you for the minimum, well, then you can see where it goes from negative to positive. Oh, it's right. It's going to be right there at 2. And then, so you got to find f of negative 6, f of 2, and f of 3. Well, how do I find f of 2, f of 3, f of, right? Remember what we talked about, part A, right? This is the derivative. How do you find if this is f prime, how do you find f? You do the antiderivative, right, of f. From where to where? Well, what's your initial condition? Where are you starting from? Negative 2. Okay, well, what are they asking for? Well, 3. So you go from negative 2 to 3. Fundamental theorem of calculus. Solve for f of 3. How do you do the integral? Well, you define the area underneath the curve. These are all shapes. And then that's how you find the values. I think that's what you're asking for, Annabelle. How to know when you use U sub? Well, Taylor, for example, like that one problem, like let's say it's f of 1/4 or f of 4 minus x squared. As soon as I see something on the inside, I'm thinking, well, I might have to use U substitution here. And start doing with that. And if you see, okay, it fits something else, then okay, then I'm right. But for example, the antiderivative of f of x dx, the antiderivative of f of, t dt, you don't need the U sub. But if you see the antiderivative of f of, 3 minus t dt, wait a minute, what's that 3 minus t doing in there? That doesn't, then you're thinking U substitute because it's something inside. Limits to infinity for Monse. That one just depends on the problem. Now, Monse, that's a really good question. But I think your focus might be off because, remember, focus on the type of FRQ that they're going to give you. They're going to give you rate accumulation, maybe. I'm hoping, as I'm thinking. There could be a limit in there. And then they can do the graph analysis, particle motion. If they do, it depends on the question. Because usually when they do a limit, I think one of the years was the limit as x approaches something of h of x over 4x or something like that. And then when you plug in, I think it was when you plug in the value, you got infinity over infinity or 0 over 0. In that case, then you would use L'Hopital's rule. That's how they would throw it. That's kind of like a bit of an oddball type of a question. And it depends, because limits at infinity, there's so much that they can ask with that. But I'm just thinking about in context of what they're giving us. Because remember, there's only 2 FRQs. So that would be like an oddball type of question. If you know what I mean. Can you explain how to calculus? You guys are doing it, guys. Remember, just you guys can do this. I know you guys are gonna be a little nervous, a little scared, right? But if you've been taking the time and practicing, just stay focused. Don't worry about the results. Focus on, you know what? Okay, do letter A, do letter B. Okay, all right, what are they asking for? Minimum. Because there's keywords, aren't there? Okay, that minimum, maximum, boom. All right. When is the particle moving left? Velocity is negative. What is the total distance? Keyword. What is, the minimum value? Where's the graph increasing? Where's the graph increasing and concave down? All those. Once you start seeing those things, it starts connecting. It starts connecting. Oh, I'm glad, Abraham. I'm glad you did well. I'm hoping you get a 5, man. I don't know, Alicia. Are they going to monitor through the webcam? Oh, I don't know. That's a good question. That's a very good. I don't know. I have no idea. They did say that they have ways to monitor cheating, and I don't know what that means. They didn't want to tell us how, but I believe them. But believe me, guys, if you've been following us and doing this together, you know, it's like, hey, I'm starting to get it. This is doable, right? At first, you're like frantic, like but once you look at all the rate accumulations, hey, they ask the same type of questions, right? Once you start looking at all the graph analysis, hey, they start at same type of questions, and they're just about recognizing them. The 2 fundamental theorem of calculus, Albert. Well, there's 2 parts of the fundamental theorem of calculus. The integral from a to b of f of x dx equals f of b minus f of a, which everybody knows. And the second part, or some people call it the first part, is when you take the derivative of the integral of f of x dx, right? The derivative cancels out the integral, and then you're left with just f of x. I think, and those are the 2 parts. If hopefully that makes sense. But if not, you can quickly Google that to see it in a picture of what I'm talking about. Alma, we are not failing. Okay, and guys, you know what? My greatest joy is to see you guys succeed. Believe it or not, I mean, it really, for teachers, for us, it really brings joy to us when you see you guys excited. Like the first time around we did this, so many people wrote back and say, "Oh man, thank you. I did it. I think I have a good chance. Oh man, I nailed it." And it's not me. You guys are the one putting in the time and the effort. You guys are the one studying. You guys are the one. All I'm doing is kind of fine tuning your area of focus. Because, I mean, if I'm talking about Riemann sum and critical points, what's a critical point? I mean, there's only so much I can do, right? If somebody doesn't know what a critical point is at this point in calculus, then it's going to be very difficult. If somebody doesn't know what's a derivative, then but you guys are putting in the time and the effort. All I'm doing is kind of fine tuning your focus, and I think you guys are doing a good job. Part 1 was easier than part 2. Conan, I know you have a test today. You guys are gonna do it, man. Okay, just stay focused. Okay, stay focused on your goal. This is about you and your future. And I know you guys can do it. Okay. No, Alma, you're not gonna fail. Breathe, breathe. One graph analysis murder. I hope so, Lily, Lil Louis. I hope so. Can you repeat the under and overestimation for trapezoid and midpoint sum? Okay, Emery. Well, Emery, normally we don't have underestimate, overestimate for trapezoidal because that one kind of fits the curve. They might ask you for trapezoidal if it's I'm sorry, they might ask you for underestimate, overestimate for left hand, right hand, or midpoint. Gosh, I don't know how you guys are seeing this, but let's say you can just draw it out. All I did is I drew it out. So this one is increasing, is going up, right? Well, if this is the right hand Riemann sum, you can see that, hey, that's an overestimate because it's what? Increasing. But you see how then it's decreasing? Well, this is decreasing, but if this is a right hand Riemann sum, hey, look at there's gaps in here. So that's be underestimate. Okay. Or the same thing with concavity, right? If it's concave down, it's going to be here, right? It's going to be an underestimate. Okay. Similar thing. So it depends on if the graph is increasing or decreasing. And think about it too. If this was a midpoint, right, the middle would be right there. And it would be also an overestimate. If the middle was here, it would still be what? Underestimate. I haven't seen them ask underestimate, overestimate with midpoints. So normally I've always seen it with left hand and right hand Riemann sum. So hopefully that helps, Emery. In BC, yes, Alma. Hopefully, I mean, this year they can't do that because of the whole situation. But normally they do give you an AB sub score and then an overall score. Okay. So yeah, even if you mess up, it's okay. But don't think like that, Alma. Just do your best. No, you're not going to be fine getting a -1, okay? Would they ever ask for an extreme value theorem? They might. Yeah, on a graph analysis. They might. And just think about, what does extreme value mean? Well, the lowest point or the highest point. That would be part of graph analysis. It might. They might be like a part D, I would say. I've seen them in part Ds. Alma. Alma, I think you just make sure you have your teddy bear. You'll be okay. Okay. You wish you were that dog instead. You guys are not gonna fail. Okay. You guys are gonna do well. Okay. All right. Just have your notes of each FRQ and just focus. Okay, guys. I know you guys can do it. Okay. That rat, yes. Yep. Good job. Good job. And it depends on the functions increasing, decreasing. So just pay attention to that, guys. And draw it out. Draw it out. A lot of times students think I have to write all this stuff out. No, just draw it out. Draw, what it looks like. Remember, as a teacher, we're looking, as a graders, they're looking for the answer. Did this person show me the answer? It could be in pictures. It could be a graph. It could be words. They're on your side, guys. But you do have to show, what you're talking about. Use arrows. Thank you, Tiffany. Good job, Tiffany. Proving differentiability. Did anybody answer that already? For Riemann sums, will they give us equal subdivisions? Yeah, they would, Mags. Normally they do. For example, they say, oh, find the 4 subintervals. They'll tell you 4 subintervals. I mean, they're equally spaced out. Or 3 subintervals or 2 subintervals, whatever it is. Same thing with midpoint, yeah. If they say find the midpoint using 2 subintervals, then you would have to do 2 equal, right? So if there's 6, then that means 3 and then 3. So you can have the middle. Albert, it depends on the graph, if the graph is increasing or decreasing. I'm so scared about cat related rates. I know you are, and I really don't know. I haven't seen a related rate problem in a very, very, very long time. So that's why I don't include it as an FRQ. I have seen it as a multiple choice. Daniel M is bold, and he's saying it won't be on the exam. Hope not. I don't think they would do that to you guys. Is there optimization? No, there hasn't been optimization in years. I don't think there's ever been optimization. Yeah, hope you guys are right. All the exams are randomized. Yeah, that's what I hear. I mean, I don't know. I don't know. How can you tell if something is concave down? Uzwa, remember, concavity is the second derivative, and you would take the second derivative, whatever it is they're asking you. If they give you a table, then you find the slope between that point. If it comes out to be negative, then it's concave down. If graph analysis, remember, this is the first derivative, right? So from here to here, it's going down. So the slope is going down. So that's the second derivative is concave down right there from here to here. And then from here to here, you see it's also still going down. Still going down. And so I know second derivative is concave down as well. So that's how you would do it with the graph. They did specifically tell us to prepare using number 4 FRQ from 2019, which kind of had related rates in it. Yeah, some people after the May exam told me, man, why did they ask us to study those? They weren't even on the test, right? They had no relation. I don't know, guys. Really, we don't know. I'm just thinking as a human being and as a teacher, what they would give us. Fundamental to calculus is that rate accumulation. Fundamental to calculus is that graph analysis. Fundamental to calculus is that particle motion. And if you look at the pattern in all the other 8 years of the AP exam, that's what's come out. Every year you get a rate accumulation. Every year you get a graph analysis. Every year you've gotten a particle motion. Almost every year you get a differential equation. Okay. I think it's almost every year you've got an area volume, which of course is not going to be on it this year. But you see the pattern? And then the table, sometimes like in 2017, 2018, 2019, you got a rate accumulation, but they gave you two equations. They didn't give you a table. So now I'm thinking, well, you know what? Maybe it's due for a table, some in there. They're not going to give you a table with a graph analysis. Actually, they might. I remember seeing that one time. But normally it's rate accumulation. But they're just trying to get creative with the questions over the years. Let me see here. Yeah, it did include a slow field. But I mean, I think you guys have been doing a pretty good job. It seems like most of you guys have been really studying, which is good. Let's see. Epic Gamer, wouldn't the midpoint sum be neither over or underestimate? I would agree with you, but it really depends on the graph and the location, if it's increasing or decreasing. If I can pinpoint, right, if I can draw those rectangles on the graph and I can locate where they're landing and I can see the function, right, then I can pretty much tell if it's under or overestimate. And I think that's probably why they don't use it, because it's hard to tell. But you can tell with a left-hand Riemann sum or right-hand Riemann sum, because either the left corner or the right corner is going to be hitting the graph. With a midpoint, you don't know. So that's why I think they don't ask the midpoint. If Michelle says, if question gives you a function g that is a rate at which a quantity is added, and they ask you g prime of t, what does g prime of t mean? Is the answer the rate of the rate, which is a quantity? Yes. Great job, Michelle. Yeah, it's the rate of the rate. It's the rate of the rate. And that's a rate accumulation. For example, if I know there was a question, I went over that on a test about the fish, the E of t and the L of t. There's fish entering and there's fish exiting. And the question asked you, remember, they gave you the rate of the fish entering, the rate of the fish entering, and the rate of the fish leaving, okay? They give you rates. And the question was, is the number of fish in the pond increasing or decreasing at t equals 5? So what do you do there? All you got to do is compare E of 5 and L of 5. What's happening? And which one is bigger? Right? Are there more fish going in, or are there more fish coming out? Okay, so hopefully that makes sense. Now let me twist the question around. So the first question was, is the number of fish increasing or decreasing at t equals 5? Now, if they ask you, is the rate of the number of fish increasing or decreasing at t equals 5, that's when you would use E prime of 5 and L prime of 5. Do you see that little difference? Is the rate in the number of fish increasing or now you're talking about taking the rate of a rate, which is the E prime of 5, L prime of 5. Hopefully that makes sense, Michelle. Yeah, guys, no slow field. I don't. Well, I'm sorry. Slow field. There was one in the previous one, so we just kind of keep it in the back of my head, know it. That's separation of variables. That's how I would do it. I mean, it depends on the question, because remember, slow field usually sometimes it's a real life scenario as well. But I mean, we don't know. Yeah, hopefully the website lets you turn in. Yeah, no, guys, I'm so sorry. I really feel bad for you guys. You're welcome, Bobby. Yeah, I mean, if it helps, even just one person, guys. I mean, I'm glad. I'm glad. I know it's a lot of information. It's crazy. Is the makeup exam harder than the one in May? You know what, Valen, we were talking about that before. I hope not. I hope they make it kind of like the same caliber, right? Rate accumulation, graph analysis. I mean, that's what I would do, because I was saying, if, hey, I did great all of a sudden, and then it doesn't submit, it doesn't upload. What's going on? It's not your fault. It's the computer. It's the glitch. That's not your fault. And then all of a sudden now you have to retake the test, and then what? The questions are completely different, and what? I don't know. I wouldn't do that. I would try to keep it the same caliber, but honestly, we don't know. That's why I tell students, just rate accumulation, know that. Graph analysis, make sure you know that. Number 2, particle motion. Number 3, differential equations. Number 4, area volume. You know, that's not going to be on it. Let's see. What if he misses exam? I don't know. I don't know for this one, guys. Somebody was saying that there was a makeup. Anna says, should we know Newton's law of cooling? No, you should not. Is the intermediate value theorem like Rolle's theorem? Yes, except f of a equals 0 and f of a equals f of b for Rolle's theorem for Anna. Sorry, guys, I'm trying to get as many questions. Will they come up with parts that are not on past exams? I don't know. What I've noticed back like in 2019, 2018, they started kind of adding a little bit of a twist to things. If you look at the 2019, they added like, you know, they added a parabola with a piecewise that consists of a parabola, and then the integral where you had to use substitution with that parabola part. But that wasn't too difficult. But Valen, to answer your question, is, I mean, they could, I don't know. But I don't think they would deviate too much from the fundamentals. Will there be trapezoidal sum, Amy? Anytime you see a table, you start thinking Riemann sum. And trapezoidal sum is part of Riemann sum. So if you don't know that, just have your notes right there handy. Let's see here. How do you justify? If the rate of change is increasing or decreasing, I usually just see if f prime and f double prime are the same sign. Is that acceptable? Karina, let me see. F prime and f are the same sign. How do you justify the rate of change increasing? How do you justify the rate of change increasing or decreasing? No, I would do that. That would be fine. Because I'm thinking, are you talking about particle motion? I think you're talking about rate accumulation. If the rate of change is increasing or decreasing, then you would take the derivative of the rate, and then you would just see if it's positive or negative. Because if f prime is positive and f double prime is negative, I mean, yeah, it's decreasing, right? The amount is decreasing. But to answer your question, is it acceptable? Yeah, I would just say that because, you know, f double prime is negative, so therefore it's decreasing, you know. Kind of like the particle motion, right? Then let's see here. What's the hardest topic in calculus that we should be aware of? Well, it depends. You know, not really. I wouldn't say hardest, Nike Nights. I would just say focus on, you know, rate accumulation. Top one, you got to know rate accumulation. Number two, you got to know graph analysis. Analyze those graphs. When it's asking for increasing, decreasing, when it's asking for concavity, when it's asking for the critical points, when it's asking for the minimum, maximum values. Okay, number three, after that would be particle motion. It's always been on the test. When is the particle moving left? When is it moving right? When is it increasing? When is decreasing? What is the absolute value of V of t dt mean? Or the absolute value of V of t? What is V of t? All right, what's the difference between V of t and absolute value of Vt? Okay, one is displacement. The other one is total distance. Absolute value is always the total distance, guys. Mena says, in the slope field graph, if the differential equation has only the y variable, how will the slope field look like? Well, I think that's just the easiest way just to see if I can show you real quick here. Let me see. Well, when you only have y, we're only dependent upon the y variable. So all your x's won't be visible. Actually, this one didn't come out. It's all vertical or nearly vertical. But let's say we don't know, right? Because remember, the slope field gives you what the graph of the original would look like. So if you say if it's only x, well then what would it look like? Well, what's the antiderivative of x? Right? It would be x squared. So it would be a parabola. So let me see if I can do it real quick here. So if it's only equal to y, you would have the dx. You do the antiderivative, ln of y. It would be your exponential. So I don't know if you can see that, Ms. Mena. But you separate it, right? I separated dy over y. And this is basic fundamental to slope field or differential equations, right? We separate the variables. All right. And then we get dy over y. We get ln of y. And then we have to solve on the other side. Remember that c, that constant, e to the x plus c. E to the c becomes that capital C. So what do you get? Oh, you get an exponential. Okay. And that's what you would see. That's what you would see. But let's say you get a question of slope field that you don't know. What do? You do that. You start separating the variables and see, oh, that's what it looks like. Because if you see y equals something, then you can kind of tell, oh, that's what it looks like, right? You get, oh, y equals 1 over 3 x squared or whatever. So that's how I would answer that question. Because they're chances are they're not going to ask. If they have another slope field, it won't be the same. They have something else, and you have to do what? Separate the variables. Okay. So hopefully that helps, Mena. The squeeze theorem. Kyojo. That's a good question. Yeah, it was in the 2019 exam. So it most likely won't appear in this year's makeup exam. I know that was an oddball, really. That one was really from, man, the squeeze theorem, I don't think it's has been there for, I don't know how long. That's really an oddball. But that was only one part. And when I did that one, I just said, you know what, I just drew it out. And that's how I'll use the squeeze theorem. I don't think it's going to be on here. If there's any indications from the May exam, nah, I don't think it was on there, but we don't know. We don't know. So in the slope field graph, if the differential equation has only the y variable, for example, dy dt of 0.5 y, how will the slope field look like? That would be the exponential again, Mina, or Mena, I'm sorry. All right. It would look like the e to the x, right? Just with that constant of 0.5. Piecewise functions, yes, and that would look like a graph analysis. Remember in 2019, they had a piecewise with that parabola there attached to it. That's what you would see. But for that one, Taylor, remember, focus on graph analysis, because you'll see a piecewise, right? But they're going to ask the same things. They're going to ask, okay, find the critical points. When is the graph increasing? When is it concave down? What's the minimum? What's the minimum? What's the minimum value? What's the, right? Those type of, they're going to ask the same type of questions. It'll be a piecewise, but they'll ask the same type of questions. Yeah, I know, Jack. I know it's hard to get motivated for this. But remember, guys, this is it. This is it right here. I think they're going to be makeup. Somebody said June 22nd. I don't know. But you know what? Stay focused. Give it your all. And knock it out. Knock it out. Okay? Just give it your best. It's only 45 minutes, right? 45 minutes. Go in there, you know, be prepared, and just go at it. Go at it. And the one thing is that since you guys have already seen it, that gives you an advantage. All right, which is good. And I think the first time around, the AP College Board has learned, and they've tried to do their best to minimize errors. All right, Benny, you're welcome. I'm glad the videos help. You're on your last limb, Ms. Alma. Alma, take this thinking test. You've come all this way. You can do it. And you know, a lot of times, you know, after the students have gone through all the videos and all this stuff, they say, you know what, man, I actually had a good chance, because now you're able to see what the test is actually asking for. Do the mock exams that College Board has on their YouTube account. Oh. Yeah, you guys are all over the world, man. Inflection point is it where the second derivative changes signs. Yeah, the inflection point is where it changes concavity, and concavity is the second derivative. So where the second derivative goes from positive to negative. You're right, Justin. So right here you see this is the first derivative, right? So if I just analyze the graph, I can see the second derivatives, right? From here to here, from -6 all the way down to 0, the graph is going down, down. So that's the second derivative is what? Going down. So that's the second derivative is negative. And then after 0, from 0 all the way to 3, the graph is going up. So it goes from the second derivative goes down, and then the second derivative goes up. So that means there's a point of inflection right there. Now, 1, 2, 3. At x equals 3, this is a very good question. The first derivative is positive. The second derivative is negative. Is there a point of inflection there? Yes. Can you find the value of that point of inflection? No, because that's a cusp. Okay, so just be careful with that. Okay, yeah, it goes, second derivative goes up, second derivative goes down. So there's a point of inflection there. But we can't find the value because it's a cusp, it's undefined. So hopefully that helps, Justin. Bilal says you heard that the May exams were very similar to the practice questions released by the College Board. I don't know. Somebody told me otherwise, but not too sure. Aditi says if it is a graph, you just have to find the area of the shapes. Yes, but remember, you have to use the fundamental theorem of calculus, Aditi. So if they ask you, for example, they'll ask you f of, like this one, f of 5, f of -6, right? So you got to do the fundamental theorem of calculus, the integral from a to b. Well, from where to what? Because remember, this is f prime. Well, how do you find f from f prime? You do the antiderivative. From where to where? Well, where do you start with? Well, what's your initial condition? Hey, they tell you it's -2. Well, -2 to what? What are they asking for? 7. Okay, you go from -2 to 7. And then you do your fundamental theorem of calculus, f of 7 minus f of -2. And then you rearrange it to solve for f of 7. And then, well, how do you find the integral? Then you use the areas underneath the curve. Okay? But you have to do it that way, step by step, that way you don't get lost. Because if you just do the area underneath the curve, you're going to be missing the initial condition. Okay? Hopefully that helps. And I'm sorry, guys, I'm trying to get to all of them. Is the rate accumulation the table one? It could be. Are they going to switch the questions? I don't know, guys. I really hope not. I mean, they are going to switch the questions, of course, but the type, I don't know. I would say I'll still stick with the same. Rate accumulation, that's my number one. I got to make sure I know. And then go from there. Graph analysis, make sure I know that one. And then go particle motion, make sure you know that one. But I guess technically all of that is fair game, right? I'm just thinking as a human being, you know, if my test, you did well, and then for some reason my system messed you guys up and it's not your fault, man, I feel bad. And believe me, they feel bad. They try to do their best, but sometimes things are out of their control. Warris, the mean value theorem is when f of x is continuous on an open on a closed interval from a to b, and where f prime of c, there's one c in between a and b, where f prime of c is equal to f of b minus f of a all over b minus a, where the derivative is equal to the instantaneous rate of change. I'm sorry, the derivative is equal to the average. Let me see if I can do this real quick. I don't want to do it on that one. So, right, here's your graph, right? This represents the average rate of change, right, from A to B. And then this is your instantaneous rate of change at point C. So that's your mean value theorem. Your extreme value theorem is, all it says is that on a continuous curve, there is a point where there is an extreme, where x equals A or B. There's one point along that A to B, where there's one point C, where there's a maximum or there's a minimum. And Rolle's theorem is similar. The only thing is f of A equals f of B. Let me see here. And I do better with graphs. So this would be the Rolle's theorem, where you see f of A and f of B are the same. So there's one point along this graph C where you have a max or a minimum, because it's continuous, and it makes sense, right? And this is the extreme value theorem, but just they call Rolle's theorem just because these two are equal. Is there an extreme value? Yeah, there's a point up here, unless it's a straight solid line, right? A straight horizontal line. But if it's continuous, there's at least one point around here called C that's you can have the up here. There's going to be a maximum or a minimum. Okay. And that's all it is. And a lot of times, guys, I use graphs just to rationalize and give the response. But and I'm so thankful, guys. You guys are helping each other out and answering everyone else. Good job. Because the more you talk about this, the more you talk about it, the easier it'll get. All right, Jack. If I give you my best tip, guys, step number one. Well, actually, if you have your notes, right, your rate accumulation, graph analysis notes, all your notes, right? And first thing is recognize the FRQ. That's it. What is it? Graph analysis. Oh, rate accumulation. Okay. What are they going to ask me for? Okay, get ready, because they're going to ask you for, the amount of this going in, the amount of people here, or the amount of this, that, right? The amount of bananas, the amount of potatoes, the amount of whatever. Okay. Think about the antiderivative. So recognize the FRQ. Once you recognize the FRQ, just fine-tune focus and go step by step and look for those key words, right? Concavity. When is the function increasing? When is it decreasing? What's the total distance? What's the absolute value of VT? All right. What's the integral of VT? When is the particle accelerating? Okay. Those things. So that's how I would approach you guys. You're welcome, Jack. I'm glad I could help, guys, any way I can. Will the test ask you to write a related rates question from the given information? I don't know. I haven't seen related rates in a very long time in an FRQ, Rion. I would probably tend to say no. Desmos can be used, yes. Mr. Mac 03. For the g of x is equal to the integral of f of x questions with a graph where the integral is from 0 to x. It's from 0 to x can be negative. When finding maximums, you have to treat g of x as a piecewise function. Well, that would be your, yeah, that's your derivative. That's usually the one that they give you. Because it says g of x is equal to the integral of f of x, right? So if you take the derivative of g, which is g prime, will give you the original f, which is probably what they're going to give you right there, the image. And that probably is going to be a piecewise, if I'm understanding you right, Sean. RKS, when you're considering the absolute minimum of a closed interval, do you only consider the endpoints and minimums or critical points? Great question. When they ask you for the absolute minimum value, yes. And that's the question. That's the key. Absolute minimum value. Then yeah, you have to do endpoints plus the 2 critical points. Okay, guys? Bridget, it says, for point of inflection, are you looking at both the changes in second derivative and concavity? Well, the second derivative is concavity, Bridget. So normally they give you the first derivative, right? And you can see, oh, well, from here, from -6 all the way down to 0, the graph is going down. So the second derivative is negative. And then after that, it goes all the way up to 3. That's positive. So the second derivative is negative, and then the second derivative is positive. So then there's a point of inflection right there at x equals 0. Hopefully that helps. BJ, let me see here and put you on timeout. Yeah, guys. Hopefully, I'll be able to make a BC videos next year. Average value. I don't know, guys. Average value. I feel that that could be part of a rate accumulation question. Excuse me. Right, because what's the average amount of people that are going from this time to this time, right? Because remember, part A might be like find the average amount of people in the store from 0 to the first 10 hours, right? So then you would do the integral, right? You 1 over b minus a, the integral from 0 to whatever 10, and then f of f, the function. Turtles, I would put it in order. Make sure you do rate accumulation, know your graph analysis, know your particle motion stuff, and then the differential equations. Looks like there was a differential equation last time, so make sure you also know that. Yeah, guys, I'm sorry about that. Will you be taking the test as well, and will you stream it? No, guys, I can't do that. I'm a teacher. I just did these videos for my students, and then just to help them out, and I can use them for next year and following years, and just to kind of help you. And I said, well, you know what? If it helps everybody else, it's good. And it looks like it has, so I'm glad, guys, especially during this year, which is kind of difficult. Do the letters have to be written in order? That's a good question, Epic Gamer. Remember, these are human beings. They're gonna look at your exam. This is probably more for the boys because the girls have pretty nice writing, right? But if it's messy and it's hard to understand, oh my goodness, right? It's difficult to find the answer. So I know it's gonna be hard, but make it easy on them. Write nice and neat. And I would say, A, B, C. If you're gonna skip an area, just leave it blank. So that way they can, right? You can come back to it. But if you have A, G, then you got to go back B, then it's going to be hard to follow along. Okay, because remember, these are human beings that are grading it. If you make it easy on them to look for the answer, find the answer, that's bonus points for you guys. But if it's hard, it's illegible, it's like, what is that? Is that a 2 or is that a negative? It's going to be difficult. All right, so Epic Gamer, so just try your best, guys, to be neat. What's the last objective on the test? Differential equations, RKS, make sure you know how to separate the variables and solve it. What's the last objective on the test? I think, guys, I mean, the fundamentals of calculus is that rate accumulation, graph analysis, particle motion, differential equations. I mean, just understanding that. I mean, that's the whole objective. Does the student understand what rate accumulation is? That's a real life scenario. And that's why we use calculus, right? Because we're using it for real life applications. And so that's why it's a #1 question that's always on the test. Graph analysis, #2, because you have to be able to analyze the data that's come in, whether on a table or on a graph. Okay. How to verify solutions? Bilal, I don't know. Normally, yes, that's typical to verifying solutions, right? And then all the other tests in the previous years that I've seen where you have to verify solutions and separate it, that's worth a lot of points. That's fundamental. But I guess in the May exam, there was only one little part. I don't know. I don't know if this time they'll change it up. But if I were you, I would. It's fundamental to differential equations, so I would just know that, how to separate them, how to solve the original, find the original given a initial condition, the particular solution, which they call it. Oh man, Constance, I'm sorry. Yeah, it's well, guys, it's just the last day, guys. When it asks about relative min and maximum, set f prime equal to 0. Next, find the critical point and draw a number line. Yeah, boops. Correct. Now you got to be careful. Remember, because one time they'll ask for what's the, the relative, the local minimum, the local maximum, right? And the other question will be find the minimum value, the maximum value. But when they ask that word value, you gotta find the value of those critical points plus the endpoints. But if they just ask for local min, local max, then you just correct. Find those x coordinates. So, but you are right. Relative min, relative max. Set f prime equal to 0. Find the critical points. Draw the number line. Then you'll be able to see what's min, what's max. If they just ask for local min, local max, you're done. If they ask for the value, the minimum value, the maximum value, then you take it a step further. Now you got to find the critical points plus those two endpoints, the values, and then just go from there. When given the graph of f of x, when is f prime of x decreasing, increasing, and concave of that? When given the graph of f of x, when is f prime of x decreasing, decreasing, okay. Eric, well, they give you the graph of f of x. When is f prime of x increasing, decreasing? You would just look at the graph. If it's going up, it's increasing. Going down is decreasing. But I think what you mean is they're not going to give you f of x. They're going to give you f prime. They're going to give you the derivative. And from the derivative, you have to find when is the graph increasing, decreasing. So if you notice here, this is the derivative. You see these here? All of these are a bunch of little slopes that are connected. They're above, right? So all of these are slopes that are positive because they're above. All these are slopes connected. These are positive slopes. So from here to here, the graph is increasing because the slopes are positive. From here to here, same thing. It's positive. The graph is increasing. From here to here, the graph, this part here, because below the x-axis, it's decreasing. Okay, so here it's decreasing. Here it's increasing. Here it's increasing. Okay. Now, what about the second derivative? Well, you got to look at the graph. So from here to here, the graph is going up, so it's increasing. From here to here, the graph is going down, so it's decreasing. So that means the second derivative is positive, second derivative is negative. That means this is a changes concavity right here, point of inflection. Okay, same thing here. The graph, second derivative is negative, second derivative all the way up here is positive. So right here is what? Another point of inflection. All right. And that's how you would do that. Are there going to be many parts? I would think so. There's only 2 questions. Two hours left. So the points of inflections are essentially zeros of the first derivative. Not quite zeros, key. The points of inflections are where it changes concavity, and concavity is the second derivative. So here, you see here, from here to here, it's going down, still going down. So from here to here, from -6 to 0, it's going down. So the second derivative is negative. And then from here, it's going up. The second derivative is positive. So second derivative goes negative, and then second derivative goes positive. So this here is the point of inflection. Same thing over here. Goes up, right? And then goes down. Second derivative is positive, second derivative is negative. So there's a point of inflection there. Okay? So that's what we mean. The midpoint theorem. You mean the Riemann sum midpoint for Chicago height? So this one here, this is a left. No, I'm sorry. It's a right Riemann sum. If it was a midpoint, then we would use, for example, these three. And then 1, 2, 3, right, from 0 to 20. And then we would use the middle y value, the middle height of 200. That's what we would use. So from here to 20, and then we would use the middle 200. Because that would be the middle between of 0 and 20. And then from 20 to 40, we would use negative 220, the y value. Because remember, all these are rectangles. So the area of a rectangle is base times height. Well, what's the base? Well, from 0 to 20. What's the height? The perpendicular height would be the middle, because it's talking about midpoint. Okay. But thank you guys so much for helping each other out. So yeah, can you give me an example where I would have to use a U substitution? Well, U substitution is pretty evident. If you see something inside the f, so for example, the integral of f of 3 minus x, right? 3 minus x is inside. Wait a minute, what's it doing inside? That's kind of weird. So then that's when you would do the U substitute. Let u equal 3 minus x, and then du is equal to negative dx. And then that's how you solve. And then you would change everything in terms of u, and you start solving it. So that's when you would use it. Eric, it says when it says g of x is the integral of f of x, does that mean that g is the prime graph? Well, what they'll tell you, like let's say if you take the derivative of g, that means you'll end up with the derivative of the integral, which cancels out, and you're left with f of x. So that means g prime is equal to the f of x. F of x will probably be the graph that they give you. So they're going to give you 9 out of 10 times, guys, that graph is going to be the derivative. That's what it's telling you. Hopefully that helps, Eric. Yeah, the graph is usually labeled. Yeah, good job, guys. Thank you guys for helping out. Alambir, when the question asks if the rate of change of some function is increasing or decreasing, then you would check if the second derivative is positive or negative. Yes. So Alambir, there's a rate question a few years back where it talks about fish entering a lake and leaving. And the question they give you a E of t, which is the rate of entering, and then the rate of leaving. E of t and L of t. These are both rates. And it asks you, the question was, is the number of fish increasing or decreasing at t equals 5? Remember, it says increasing or decreasing. I'll say it again. Is the number of fish in the lake increasing or decreasing at t equals 5? Then all you got to do is plug in 5, E of 5, L of 5, compare those two. But if it says, is the rate in the number of fish increasing or decreasing at t equals 5, then you have to do E prime of 5 and L prime of 5. And hopefully that makes sense. So be careful, the wording is a little bit off sometimes. Honeybee says, can I do an example of rate accumulation? Oh man, it would take a while, sorry, señorita. But if you look at the one I usually, I have a whole series of videos on them. I did one for 2018. So 2018 is this one, right? They gave you something like this. The first question, Honeybee, it says, how many people enter the line for the escalator? How many? What do they give me? Boom, a rate. How do I find an amount from a rate? You integrate the rate, and you get an amount. So this would be the integral from 0 to 300, and that would be it. That's it. But then there's other parts of the rate accumulation. Okay, it says how many people are in line at t equals 300. Remember, with rate accumulations, honeybee, you got to take into consideration everything. So in this 2018 question, there's people waiting, okay? There's people entering, and there's people exiting. There's a rate of entering, there's a rate of exiting. So there's 20 people waiting, plus, why plus? Because the rate is increasing. The people are getting on, okay? Minus, okay, well, let me go back. 20 plus the integral of the rate, RT dt. Why the integral? Because when you integrate a rate, you get an amount. Minus the integral of the other rate, which is exiting. Why minus? Because the people are exiting. So that's your general equation. And then from there, they're going to ask you, this one from 0 to 300. So then you go from 0 to 300. And that's, so you incorporate everything. And you let your calculator do the work. And then from there, they're going to ask you find the time when there's a minimum number of people or the maximum number of people. So then you got to do what? First derivative, set it equal to 0, find your critical points, and then test those critical points and the endpoints. Okay. So it's not just one part of it, honeybee. It's just a lot of parts to it, and hopefully that makes sense. So I would encourage you, if you're having trouble with that, look at the other video examples, and hopefully it makes sense. Monse is asking, can you explain the difference between the mean value theorem and the intermediate value theorem and how we use it? Usually I've seen the mean value theorem, guys, with tables. That's how I've seen it. Okay. But this is your mean value theorem here, guys. All it says, Monse, is you have a continuous function. So think about it. During this function, at some point here, the average rate of change, right? The average rate of change is from here to here. Okay. And think about a car traveling, right? Sometimes you go faster, sometimes you go slower. When you go up slow, you go slower. When you go downhill, you go faster. But there's an average speed, right? Average velocity. Okay. Well, at some point along this continuous curve, right, there's one point where the instantaneous velocity, instantaneous rate of change is equal to your average rate of change. Okay. And that's what the mean value theorem tells you. The average, right, from geometry, the mean value. That's where it says that this instantaneous rate of change equals the average rate of change. And that's what it means. All right. And the intermediate value theorem, let me see if I can draw it here. Well, if you think about it, what does intermediate mean? Well, in the middle, right? Well, if you have a continuous function, the continuous function from A to B, they just tell you there's one C that's between these 2 points, these two values. There's a f of C that's between these two values. And that makes sense because it's continuous. And a lot of times what you'll see is that they'll probably give it to you as a table. I know one of the questions before was like a table. Yeah, and they'll ask you, is there a time between here and here where f prime of C equals 0? Or f of C is equal to 0? And you can say, based on the intermediate value theorem, yeah, because this goes from, let's say this was +4, and then this is -5. then of course it has to hit 0 because you go to -5. But what do I do to explain it? I drew a picture, right? I don't like the words too much. I think it's too cumbersome. But pictures here, and then you can put whatever value here. Maybe put 5 here, -4 here, if that's what they give you, and then you just do that. All right, guys. Hopefully that makes sense, Monty. Point slope form and finding the tangent line. Well, Eshna, the tangent line is the derivative. That's basically your keyword for the derivative. Point slope form. So it's y minus y1 equals m times x minus x1. So they'll give you a point. So you plug in your x and your y. And to find the equation of the tangent line, you just got to find, usually it'll give you like the derivative. Here it is. So this is from 2015. Yeah. See, remember, this is the derivative. This gives you the slope. So all you do, they give you your initial condition for this one is at 2, 3. Okay. So you plug in x equals 2, you plug in x equals 3, x equals 2, y equals 3 into here. Now you have your slope. And then you plug in these points, right, 2 and 3. X is 2, y is 3, and then you plug in whatever slope you get from here. And that's how you find your equation of the line, y minus y1. Hopefully it makes sense. But that's it. Implicit differentiation, that's normally, can you give an example? Do I think it'll be on the test? I don't think so. Has there ever been an implicit differentiation? I think there probably has in a years back. That's from your differential equations. So for example, they might ask you to find the second derivative of this, right? So you got to find the derivative of this, 2x minus y. So you would do the derivative of 2x, which would be 2, minus the derivative of y. The derivative of y is what? Dy dx. So the second derivative would be 2 minus dy dx. But you can't leave it like that. You got to plug in dy dx. Well, what's dy dx? Is this guy. So you would put 2 minus parentheses 2x minus y. And that would give you your second derivative. That's how that's how they normally would do implicit differentiation. I really don't know if they'll put that on there. I guess they could. I mean, it's part of differential equations, but I'm not too sure. I hope College Board gives you something straightforward. Is graph analysis going to be the first FRQ? I don't know, guys. I really don't know. I do know that the first question is worth 60%. The second question is worth 40%. I really don't know. I hope they keep the format the same. Hopefully the first one is a rate accumulation. Hopefully the second one is a graph analysis. Those are fundamental to calculus. And I would say they are, that's how they do it, guys. Is integration by substitution even on the test? If you notice in 2019 it was. I could see them doing that for a graph analysis question. I think yeah. I think in the 2019 release ones, I think there was on it something like that. So yeah, just be ready for it. Use substitution is not too difficult. let u equal the inside part. Pretty straightforward. And for a problem asking for the absolute extrema, can you justify it by saying extreme value theorem? I think you might need to do a little bit more for that, Daib. I'd have to look at the question you're talking about. You could say the extreme value theorem, but then you would have to explain a little bit more. I don't know if you're talking about a graph analysis where it's asking you for the maximum and the minimum. Because if they're asking for the maximum value, the minimum value, then you would have to actually find those values. If you're talking about the, like let's say they give you a graph and they're asking you, is there a point f of c where it equals 0 or f prime of c equals 0? Then you can say, oh, based on the intermediate value theorem, this happens, or based on the extreme value theorem, this happens. You would have to go into a little bit more of an explanation, I think. You would, I think so. You would probably have to say, based on the extreme value theorem, this and this happens, so this and this is in here. Because remember, the extreme value theorem, it just says you have a continuous function. So anywhere along that point, you're going to have some type of extreme value, a maximum or a minimum. So whatever values they give you, you can say between this point and this point, then you know what? Yeah, there's a point here. So for example, let's say x equals 5. It goes from positive 5 to negative 2. Is there a point in which, f prime of c equals 0? Then you would say, yeah, because it goes from positive 5 to negative 2. Yeah, it has to cross 0 because it's continuous. So you would do a little bit more of an explanation. I would. So hopefully that answers your question. Yeah, anything, guys, anything that's kind of justify your explanation. Sometimes it's drawing pictures. Remember, these are human beings. So the easier you make it for them, that's okay. It doesn't say not to draw pictures. It doesn't say, it just says justify. Can you justify drawing a picture? Yeah, draw a graph. Here's my number line. Here's my number line. Boom, boom, boom. It goes from negative to positive, and hey, there it is. That's okay. Okay, because it doesn't say that you can't justify for any other reason. How do you do integrals of things like g of f of x? Mujo, that looks like a u substitution. Yeah, because that's a composite function. So you let u equal f of x, and then du is equal to f prime of x dx. And then maybe they give you a value of f prime of x. But I'd have to look at the specific question that you're talking about. Daniel says, my teacher says there's going to be a differential equation like 90% of the time. Yeah, normally those, yeah, it's fun, normally fundamental. But I mean, this year you only get 2 questions. So that's the tough part. But I would make sure I know how to separate variables, write the particular solution. Okay, so u substitution, let's see. Something like this, guys, probably. Right, see, there's something inside, right? like, wait a minute, that looks weird. How do I do that? So that's what tells me I got to do u substitution. So I'm going to let u equal the inside. So then du is equal to negative 2x dx. Right, and then you can see, well then, oh, the x dx is going to get filled in with here x and dx. That's going to be my negative 1/2 du, and then this becomes f of u, and then that becomes your basic integral that you can do. And then just don't forget to change the limits of integration from a to b. Right, if a is 0 and b is 1, you plug in 0 there, and that way you change the terms of your limits. So that's how I would. I've seen that. I've seen that. Will the College Board just straight up understand extreme value theorem, intermediate IV theorem? Yeah, they would, I think. You mean as far as spelling it out? I don't know. That's a good question. I mean, I would. These are teachers. I think I would say yes, but it would take, what, a few more seconds just to write out the whole thing, mean value theorem? Or you can just put mean value and then th. But I don't know. That's a good question. If I were me, I would probably just write it out just to be on the safe side. I'd have to ask people that are graders. I don't know. It's hard. Is the latter problem going to be on the test? No, that's a related rate. That's usually like a multiple choice. Let me see here. When would you use the average value of a function? They'll ask you. They'll tell you, what's the average amount of fish in the pond? Or what's the average value of this, of the function? What's the average amount of bananas? Then you use 1 over b minus a. Do I have any prediction will be on the test? Will it look similar to the previous test? I don't know, guys. I'm hoping it looks similar, right? Rate accumulation, graph analysis, and go from there. But I really don't know. I mean, technically there's those 5 types, right? Area volume not going to be on there. So all of that is fair game. Rate accumulation, graph analysis, different particle motion, and then differential equations. And they'll throw in a table in there with the rate accumulation or the particle motion. But honestly, we don't know. All that is fair game. I hope they don't throw an oddball. I don't think they would, but never know. But just hang in there, guys. Their last one. Yeah, it's June. Yeah, related rates are kind of tough. If they give the horizontal tangent, is it safe to assume that those are the inflection points? Not necessarily. Remember, inflection points, you got to analyze the graph of the second derivative. Actually, I think you're right. You might be right, Justin. Yeah, because let's see here. I'm just thinking about this one right here, right? This is the first derivative. And what's the second derivative, right? You have a horizontal tangent right here, horizontal tangent right there. But I would still just go from the graph and analyze it just to make sure. But it seems like you're on the right track. But just double check it. It's not that hard. Because they're getting very, very creative with how they ask the questions. Yeah, BC, Taylor polynomials, that's fundamental. Taylor series, I don't know. They'll have 2 questions, so who knows? Eshna explained how to do the stuff when you have to graph and they ask you to integrate something like 2 times the function of that graph. That would go into u substitution, let u equal the inside part. And then from there, do it like I was explaining, and then just go step by step. And then everything would be in terms of f of u du, and with limits from u. And then you can go ahead and solve it and find the area underneath the curve. But that's what normally you would have to do when something's on the inside, like 2f of something, f of x squared minus 4 or something like that. Will you have to use trapezoidal sum? I don't know. But anytime you see a table, you're thinking Riemann sum, and trapezoidal sum is part of that. So if you're not too familiar with that, make sure you have your notes right there. Fundamental theorem of calculus, that's usually, that's the integral from a to b of f of x dx equals f of b minus f of a. Usually they'll ask you that with a rate accumulation or a graph analysis, I'm sorry. So that's just fundamental, just to, if they're asking for example f of 6, for example here, right? Find the values. And you go find f of 5, right? Well, they give you the derivative. Well, then if they give you the derivative, how do you find f? You do the antiderivative. And then where do you start from? Well, they give you the initial condition, f of -2. So you go from negative. Well, how do you solve the integral? The integral would be the area underneath the curve. And then you would just, that's how you would do it, guys. Pencil or pen, whatever is easier for you. I think the camera will capture both. I would say use pencil. If if you make a mistake, you can erase it. Tyler, for L'Hopital's rule, you can do it as many times as needed. As long as you keep getting 0 over 0 or infinity over infinity, then you keep doing it. So you get 0 over 0, L'Hopital's rule. 0 over 0, L'Hopital's rule. 0 over 1, then 0 divided by 1 is 0, so you're done. Or if you get 1 over 0. So as long as you keep getting 0 over 0, you keep doing L'Hopital. How do you know when to find the area underneath the curve? The area underneath the curve, Anaya, is when you have the integral of f of x dx. And how do you know when you simply plug in the bounds? It depends on the question that you're asking. I'd have to see specific, but I think you're asking about this one when they find the values. When they ask you to find the values, when you plug in the values, when they ask for a specific value. My watch is too big. Thank you. night, Tyler. When you have the second fundamental theorem, is it G double prime of X? No, the second fundamental theorem, because I think you're talking about the second part. There's two parts. The first part is just the integral from a to b of f of x dx equals f of b minus f of a. The other part is where you take the derivative of the integral and the derivative and the integral cancel out, and you're just left with the f function, f of x. Basically, it's saying that the derivative and the integral are inverses of each other. They cancel each other out. That's the second part. That would be probably more like an oddball question. But remember, guys, stick to the fundamentals of the main topics. If they ask something like that, L'Hopital's, I know, but that was like an oddball question. L'Hopital's, if you take a look back, L'Hopital's, that usually doesn't come up. I'm hoping they just stick into the fundamentals for this year. Will type in Google Docs be good enough? It depends on you, whatever you're more comfortable with. If you're gonna do, if you haven't used Google Docs before and this is your first time doing it and doing math with Google Docs, it might be a little bit tough. If you're more comfortable doing, yeah, guys, just try to make it as easy as possible for yourselves. Seen that question with rate accumulation, so I don't know about that. Because rate accumulation, right? What's the average amount of people that are waiting in line? So you would do 1 over b minus a. Yeah, guys, thank you guys so much for helping out and answering each other's questions. How do I switch sums into definite integrals? I think you're talking about sigma. That probably won't be on the test. Gosh, if it was, that would be an oddball. Let me see if I can give you an example of that one. That's NMA. Let me see here. Well, this is kind of simplified here, but NMA, this probably won't be on the test. I guess you never know, but this could be an oddball. But if they give you a sigma delta x, that's your dx. Now delta x is b minus a over n. So if you see here like 4 minus 3, that gives you your subdivision. But you normally would go from here to here, a to b. Okay, and that would be 4 minus 3 over 2n. That would be your delta x right here. And that would be here. But your f of x would be just here. So your a to b would be here, a to b. Your dx would be this delta here. So you might have a value here outside, like a 4, like a 1. But I'd have to give you a better example, and I don't know if you guys have seen it backwards. So it's kind of tough. But NMA, I would say, I'm going to go out on a limb, and I'm going to say that's probably not going to be on the test. And I wish I could come up with a better example. And I don't know if you guys are seeing it backwards like I am. Hopefully you're not. But again, guys, I think I would just go back to the fundamentals. Stick with the fundamentals. I think you'll be fine. Yeah, guys, I'm sorry. I wish we had more time, and which we don't. Optimization, constants, optimization is not going to be on the test. Hasn't been on the test for years. I don't think it's ever been on test. Tyler, yes. Yeah, that's what a slow field is. Anybody? And then, how do you read P of A? Piecewise value graph. I would just say FRQ, graph analysis, then go into, I would say those 4, FRQ, do an FRQ, look at the videos, do one FRQ, do a graph analysis, do a particle motion, do a differential equation. Hopefully you've been watching the other ones up to this point, and then it makes more sense. But that's what I would do. Okay, you kind of get the hang of what they're looking for. All right, Constance, good luck on your BC exam. Good luck to everyone. Go get that 5. SS, so the intermediate value theorem, think about the word intermediate, in the middle. There's something in the middle. The intermediate value theorem just says that you have a continuous function. Okay, and basically if you're going from, let me give a graph. Let's say this is 10, right? And then this is 2. Okay, that equals 2. A equals, I don't know, we'll go 1, 2, go 6. All right, so this is a continuous function from A to B. All right, from 1, x equals 1 to x equals 6. At x equals 1, the y value is 10. At x equals 6, the y value is, what did I put there? 2. All right. Is there a point where f of c is equal to 3? Yeah, because there's no way you can go from 10 to 2. Okay, so normally how do you see that on a test? You'll see the table of values, like a table, like Riemann Sum, like values. And then they'll ask you, explain why it's a graph here, and then just label it, and then you say, hey, here's 3. That's how you use intermediate value theorem. And that's why they call it intermediate, right? It's in the middle. The mean value theorem is this guy. Mean value, well, what's the mean? Remember from geometry, means the average. Well, how do you find the average, right? You're taking a road trip. Well, from A to B, right? What's the average? Because sometimes you go 30 miles an hour, sometimes you go 60, sometimes you go 70. So right, you're going, depends on you're going uphill or downhill. But then overall, the whole trip, you have an average velocity. Well, that's what the average here. But the mean value theorem tells you that at here, the average is equal to the instantaneous rate of change. F prime of c is the instantaneous rate of change. 6, you have a 90. Can you tell me that you have gotten at least one A in all the tests that you've taken? Of course, because your average is an A. There's no way that you have a D in the class. Okay, let's say you have a D in the class. There's no way you've ever gotten an A on the exam, on any exam. Okay. Unless it's worth a lot more. But actually, let me give you a better example. Let me do it the other way around. There's no way that you have an A on the grade in the class, and you've just gotten a bunch of D's and F's. There's no way that can happen. There's got to be at least one time where you. That's what this is telling you. It's continuous. The instantaneous rate of change equals the average value. Now, how would they see that on the test? Same thing again. They would ask you. They'd say, explain why f prime of c equals this, this, or this. Or is there a point f prime of c that equals 0? And then you would look at the table, and then you would use the mean value theorem, which would be this. Which would be this. So you would set whatever the and normally that's how they would do it. And the extreme value theorem is just this one. This is Rolle's theorem, where f over a and b are equal to each other. But the extreme value theorem, just saying that you have a continuous function. Is there a point somewhere on here where there's an extreme value, where there's a maximum or there's a minimum? Well, the answer is yeah. There is. It may just make sense, right? You have a continuous function. There's got to be a maximum or a minimum, whatever that is. I don't know how the function looks, but I know that. How would they ask you on the test? I think it would probably be like normally with a table question. Yeah, that's how it'd be, a table question. Because if you have a graph analysis and they ask you for the minimum value, the maximum value, then you got to take the derivative, set it equal to 0, and then find your critical points number line, and then actually find the values of those points, the critical points and the endpoints. So hopefully that helps SS. All right, guys. When are you guys signing in for your test? The normal line, Eshna. Normal line. That's just the perpendicular line. So you would use instead of you know, let's say you know how you find the tangent line. The normal line is just the opposite reciprocal of the tangent. So 3:30 Eastern time. 12:30. All right. An hour from now. All right. Eshna, the normal line. Honestly, I don't think it's gonna be on the test. But let's see here. See if I can do it real quick here. Well, if you know how to find the tangent line, and I'm hoping you do, Esna. Let's see here. Y minus 3 equals 2x minus x1. Sorry, I'll make that a number. So you see that, guys? Eshna? So this is your normal tangent line, right? The slope. Well, the normal line is just the opposite, which is from positive to negative, and the reciprocal. Because the normal line is a perpendicular line, and that's the only difference. Yeah, negative reciprocal. Good. Yeah, guys, the questions are pretty straightforward. I think you guys have a good chance of getting a 5. The other ones, the first time around, they said they felt pretty good. I mean, the majority of them. Of course, if you've never studied and haven't been studying, and then you're trying to cram everything in an hour, then it's going to be difficult. The derivative of an inverse trig, please. Trig. So I think you'll be safe. Remember, study those 5 FRQs. Actually, 4 for this year. Rate accumulation, graph analysis, particle motion, differential equations. The important topics, Ajala, yeah, just rate accumulation, graph analysis. Those are my top 2, just because those are always, I've always seen them on the test. And then particle motion, I've always seen that on the test. It was, see here. If you get a 5 for this, I'm going sleepy early. Sleep early. Should we expect almost identical to what was on the first exam? I don't know. Well, as a teacher, I would never give the same exam because, of course, students are going to try to cheat. There's always one. What I would do is I would try to keep it relatively the same, a rate accumulation, graph analysis. But the AP exam, the College Board says that the other ones are fair game too. Yeah. For me, if I knew that my system caused a lot of this mess, I would not try to deviate from the fundamentals because it was my system's fault. You know, you did good on the first test. Yeah, I got it. I can't upload it. I can't submit. And then the time runs out. So you're frustrated. You did all this work. You did great. What the heck? What happened? So I just want to kind of stick to the fundamentals. But again, I mean, I don't know. I really don't. So but that's why I'm saying rate accumulation first, graph analysis second, particle motion just to be on the safe side, and differential equations. If you guys know that, I think everything else, like, you know, they might throw you a little curveball, maybe like a, I don't know, product rule, quotient rule, L'Hopital, maybe. You know, you guys are asking about that. But I think you guys have a good chance of getting a 5. They should let us, yeah. I don't know. Normally there's 9 questions for both parts. 9 questions for part 1, 9 questions for the second question. Now, the first question is going to be worth 60% of your overall score. That's what we know. So I'm hoping that they give you a rate accumulation, because that's just fundamental to calculus. And then I'm hoping the second question is like a graph analysis. Hopefully they don't deviate from the norm. I heard that there were 4 parts, right? 4 parts the first one, 4 parts the second one, but they didn't do that. But it seems like it's going to be percent. For a 4, it comes out to be, I think, 48%, right around there. For a 3, it comes out to be about 36%. So let's say we have, right, 9 points, right? 40% of 18, that's 40, right? 7.2. So what I tell my students, I think if you get half of the question in the first part, half of the second one, you should be good. But then again, remember the first part is going to be the big bulk, the one that's going to be worth the more. So if you can hammer out the first one, you're really on your way of doing well, And I'm hoping that they don't change it. Hopefully they can, it's a rate accumulation. But again, I mean, we just don't know. They can do whatever they want. Okay. You might need a few points left. Maybe, let me see. If let's say 18 points, and then let's say you do 6, I think it's like 63%. You would need 11 total points. So you would need a couple more points for the second part. I'm just guessing. But remember, guys, don't focus on just answering this many questions. Answer all of them, even if it's just partial. Because remember, when I was doing those videos, some questions, like answer, they might give you 1 point for the integral, 1 point for the answer. So that's 2 points there. But you might know how to set up the integral, but you might just not get the answer. Well, that's at least to the best of your ability. Online calculator, I like Desmos because it could do the integrals. It could also do the graphing and find the point of intersection. Somebody else was saying Symbol Lab, which is good. Whatever it is you're comfortable with. Will I have a chance to get a 3 if I only get 2 questions right from all the questions? No, I doubt that, Aaron. But remember, you want to just answer all the questions as best as your ability. Now, if you've been following us and watching the videos, then it's starting to click. It's starting to make sense. Okay. And the related rates and the ladder, that's probably won't going to be on the test. Related rates, I think I haven't seen a related rates question on FRQs since 2011, maybe 2001. One of those two. It's been a long, long time. No, they got bigger questions than that. That's more of a multiple choice question. Okay. Let me see here. How to write an expression for the rate of change, Tyler? I don't. Remember, guys, rate accumulation, it's a real life scenario, so you got to incorporate everything. Like the fish, right? I'll give you 2 examples. One year it was about the fish entering in a pond. So there was no fish in the pond to begin with. So then you don't start with anything. And then you have the E of t, the entering rate. So you do the integral of E of t minus the integral of L of t. Why? Well, why minus? Well, because fish are exiting, they're leaving, right? So your equation would be A of t equals the integral of. The year we had an escalator problem where they say 20 people were waiting in line for the escalator. And then R of t gives you the rate of people getting on the escalator. And then they say the rate in which people are exiting the escalator is given by this. So then what's your equation? A of t is equal to 20, because that's already what's in there, plus the integral of RT dt. Well, why the integral? Because when you integrate a rate, you get an amount. And A of t is the amount of people that are in line at any given time. So A of t is equal to 20 plus the integral of RT dt minus, well, why minus? Because people are exiting the escalator of whatever that rate is. Okay. And that's how you set it up. Now, I'll give you another scenario as well. There was one time they gave a year bananas. Employees at a grocery store. There's, I think, I don't know, I think I'll just make up a number. 80 bananas or 80 pounds of bananas on a table. And then they open the store. So for the first 3 hours, people are taking the bananas, right? But then after 3 hours, the employees started adding bananas. So then how would you write that scenario? Well, you would write A of t amount, A of t equals the, what did I say, 80 pounds? 80 plus the integral of what? Of, I don't know, let's do f of t dt, right? The adding of the bananas, okay? Well, when did you start adding the bananas? You didn't start adding the bananas at 0. You started adding the bananas through. You got to take in consideration everything. So that's why I say taking a mental picture of what's going on really helps you out. Because remember, if one, sometimes the initial value is 0, initial condition is 0. Sometimes it's, they start adding bananas after 3 hours. So you just got to really take everything in consideration. But the rate accumulation is something's usually there. You're adding something, something's going in, a rating going in, so that's addition, minus something is going out. And you just got to pay attention to little nuances there. Hopefully that helps. Find as the slope of the first. Yes, Tyler. Yeah, they use all different things. Bananas, potatoes, they use all kinds of stuff, guys. Coffee. Do you have to show? No, I just remember these are calculus teachers. So if you show what I show you, you should be. Ananya, how do I find the minimum value for a given interval? That's a graph analysis, and for that one, they're going to give you a f prime, right? So what do? How do you find f, the value of f, given a derivative? Well, you do the antiderivative. Okay. Well, where do I start out, right? The antiderivative is the integral. Well, from -2 to where? Well, what are they asking you? They're asking you the value of f of 5. So you the antiderivative from -2 to 5. And then you do your fundamental theorem, which is f of b minus f of a, which would be f of 5 minus f of -2. And then you solve for f of 5. And then they tell you the initial condition is here, right? Well, then how do you do the integral, right? The integral. Then you would do the area underneath the curve from whatever it is, from -2 to 5. So where's -2? -2 to 5. So you would go the area of the semicircle all the way up to here, right? So this is going to be a pi r squared divided by. Oh, I'm sorry. Now you said the minimum value for a given interval. Find your critical points. Do your number line. Once you find your critical points, then you got to test those critical points. Find the values of those critical points and the endpoints. Well, how do you do that? Well, that's what I was talking about here, the first part. Right? So let's say your critical point is -2. So then you would have to find f of -2. Just like I did, like I was explaining with the fundamental theorem. The antiderivative from -2 to whatever, and do that way. All right. What's the difference between critical points and critical numbers? Can endpoints also be relative min, relative max? The endpoints, they could be absolute minimum, absolute max, yes. And remember, the key to that one, Tyler, is they're going to be asking for what's the absolute minimum value? What's the absolute maximum value? When you see that word, then you know you have to find both the endpoints and the critical of f based on the graph of f prime. Ahmed, great question. Remember, critical points is where the first derivative is equal to 0. Well, this is the first derivative, right? Where's it equal to 0? Where it crosses the x-axis. So you have 3 critical points here, here, here. And so where is it a minimum? Well, it goes from negative, where the slope goes from negative to positive. So it goes from positive to negative. That's a max. It goes from negative to positive. That's a minimum. Okay, that's a critical point right here. It is a critical point, but we don't know what happens there. So right here, there's neither a minimum nor a maximum because we don't know what happens afterwards. So here and here, those are our 2 candidates. And then if it's asking you for the minimum value, so then you got to find the value of this guy. You got to find the value from. Will this retake be harder than the May exam? I don't know, guys. I hope not. Hopefully it's in the same caliber. For the candidates test, do you find the values of the endpoints? Kaylee, remember, if they ask you, okay, that's it. But if it asks you, find the local, the relative max, relative min. Okay, x equals 2. See here. Yeah, guys, if you can't, you can go ahead and email your photos, which would be great. I wish I would have done that the first time around. But you live and learn. Yeah, that is a critical point. But it is a critical point, but we don't know what it is. Does that make sense? We don't know if it's a max or min because we don't know min, so we don't know. So we're not going to use it. We're only going to use the other 2. But it is a critical point. Because why? Because the first derivative is equals to 0 at that point. Well, the first derivative test is to find out where the graph is increasing or decreasing. That's your number line. The second derivative test is concavity, and you can use it also to find the minimum, maximum. But remember, guys, think about the questions from the test, because if you focus on the type of questions that I've showed you guys from previous exams, those are going to be relatively what you're going to see. So you're not going to see second derivative test. You're not going to see first. They're going to see concavity. They're going to see when is the graph increasing, decreasing. So you got to be able to understand what they're telling you there. How do you find the concavity if you only have f of x for the graph? Well, when they give you the graph analysis, Daniel, they're going to give you f. So from here to here, it goes down, right? So the graph is going down. So the second derivative is negative. And then from here to here, the graph is what? Going up. I mean, it's positive. So it goes from second derivative negative, second derivative positive. So what? There's a point of inflection there. That means there's a concavity there, changing concavity. So that's how we would analyze it. Oh, you're welcome, Abraham. I'm so glad I was able to help you guys out. Do I have a video explaining this one? Yeah, 2017. Yeah, go ahead and look at calculus. AP Calc. Everybody has different questions, and I want to give you guys time to prepare and get ready. I want to wish you guys all the best, guys. Work hard, stay focused. Remember, this is about you. You put in all this time and the effort, and do your best, man. I really think you're going to give yourself a really, really good chance of passing the exam. All right, guys? So, yeah, 1 hour and 14 minutes, guys. So I'm going to give you guys some time just to take a break, relax, mental break, go back and study a few things, get yourselves organized. Yeah, 1 hour and 15 minutes, guys. So just to finally prep up. All right, guys? Thank you guys so much for your time. I know it's been hard, frustrating, you know, but I wish you guys the best. All right, guys? All right, guys. I'll talk to you guys later. Good luck, guys.